वेलकम टू गेट 2024 सॉल्यूशंस फॉर इलेक्ट्रॉनिक्स एंड कम्युनिकेशन पेपर। तो दोस्तों, आज का जो पेपर हुआ है, जो स्टूडेंट से फीडबैक मिला है उसके अकॉर्डिंग द डिफ़िकल्टी लेवल इज़ लिटिल हायर देन द लास्ट ईयर। बट ऐसा भी नहीं है कि पेपर बहुत ज़्यादा टफ था। हाँ, कुछ क्वेश्चंस लेंदी समझ में आए हैं। जो भी क्वेश्चंस हम लोगों को रिसीव हुए हैं, 2000 मेमोरी बेस्ड क्वेश्चंस, तो उसी के अकॉर्डिंग इसका डिस्कशन होगा। ऑलमोस्ट मोस्ट ऑफ द क्वेश्चंस आर अवेलेबल एंड द मोस्ट क्लोजेस्ट आंसर्स विल बी गिवन। सो हमारे जो कंसर्न टीचर्स हैं एक एक करके सभी सब्जेक्ट को डिस्कस करेंगे। कुछ चीज़ें मैं आपको और बताना चाहता हूँ कि गेट इज़ डन, बट आफ्टर दिस गेट एग्जामिनेशन यू हैव टू रिकंसॉलिडेट योर सेल्फ। देखिए कि आपकी परफॉर्मेंस कैसी रही, क्वेश्चंस कितने सही हुए, कितने गलत हैं, कितने मार्क्स आ सकते हैं। और 2 दिन 3 दिन के बाद फिर आपको आगे की प्लानिंग स्टार्ट करना है। और जो लोग इंजीनियरिंग सर्विस प्रीलिम्स लिख रहे हैं उनको ईएस के लिए आज से ही लग जाना है एंड राइट योर एग्जामिनेशन विद द बेस्ट पॉसिबल एफर्ट्स। तो एक हफ्ता जो टाइम बचा हुआ है उसमें कंसोलिडेट करिए अपने जीएस के पेपर को और उसको अच्छे से लिखिए। I will come with a live session on Tuesday, that is day after tomorrow, at 7:30 p.m. and I will share the tricks and tips how to attempt ESC paper 1। मतलब प्रीलिम्स का जो पेपर होगा आईईएस का, कैसे अटेम्प्ट करें, क्या उसमें आप ट्रिक्स अप्लाई कर सकते हैं, किस तरह के क्वेश्चंस आते हैं, कितना अटेम्प्ट करना सही होगा, उस पर बात करेंगे। साथ ही जो सेकंड पेपर है उसके बारे में भी हम एक्सपर्ट से बात करेंगे। तो उस सेशन को देखना ना भूलें। दैट विल बी वेरी यूजफुल फॉर दोज हु आर प्लानिंग टू राइट इंजीनियरिंग सर्विसेज प्रीलिम्स। इनफैक्ट अगर आप आईईएस नहीं भी दे रहे हैं तो भी उस सेशन से आपको हेल्प मिलेगी कि किसी भी कॉम्पिटिटिव एग्जाम में जहाँ पे जनरल स्टडीज के क्वेश्चंस पूछे जाते हैं, कैसे अपने लिमिटेड नॉलेज से आप ज़्यादा एफिशिएंट परफॉर्मेंस कर सकते हैं। तो उस पर डिस्कशन करेंगे दोस्तों। और मैं बताना चाहूँगा कि इस बार मेड इजी ऑलमोस्ट 2 डिकेड्स हो गए। 2001 के बाद ऑलमोस्ट 2023 है ये, तो 23 साल की जर्नी पूरी हो गई। और इस पीरियड में मेड इजी के जो रिजल्ट्स रहे वो बहुत अच्छे रहे। और हर साल क्लास से ही, चाहे वो इंजीनियरिंग सर्विस हो या फिर गेट हो, हर साल मेड इजी के क्लासरूम स्टूडेंट्स या ऑनलाइन स्टूडेंट्स ही अच्छे रैंक लाते आए हैं, टॉप करते रहे। हम लोगों ने पिछले 20 साल के एक्सपीरियंस को यूज करके इस बार बहुत ब्रेन स्टॉर्मिंग की है और मेड इजी के सभी टीचर्स ने बैठ करके कोर्स को रीस्ट्रक्चर किया है। अब ऑनलाइन के कोर्सेज और ही एफिशिएंट तरीके से अवेलेबल होंगे और ऑफलाइन में कुछ डिफरेंट मेथोडोलॉजी होगी और बहुत अच्छे तरीके से कराए जाएंगे। तो मेड इजी का एक नया वर्जन आने वाला है, दैट विल बी लॉन्च्ड आफ्टर 1 वीक ऑन द डे ऑफ इंजीनियरिंग सर्विसेज प्रीलिम्स एग्जामिनेशन। और उसमें हम न्यू मैकेनिज्म जो हम लॉन्च करने वाले हैं कि व्हाट विल बी द न्यू वर्जन ऑफ द मेड इजी 2.0, उस पर बात करेंगे कि क्या नए कोर्सेस ला रहे हैं। क्योंकि बहुत सारे कॉलेज गोइंग स्टूडेंट्स हैं जो अभी फर्स्ट ईयर में हैं, सेकेंड ईयर में हैं, उनके फंडामेंटल्स वीक हैं या आगे चल के उनको किसी कॉम्पिटिटिव एग्जाम को लिखना है, तो उनके लिए भी बेसिक कॉन्सेप्ट्स ऑफ इंजीनियरिंग लेकर के आएंगे जो कि क्वालिटी टीचिंग के साथ बहुत ही अफोर्डेबल प्राइसेस में अवेलेबल होंगे। और जो ये मेड इजी 2.0 होगा, मतलब नया वर्जन होगा, इसमें कोर्स की फीस स्ट्रक्चरिंग भी दोबारा की गई है। कई जगह कोर्स की फीस को कम किया जाएगा, कहीं पर लगेगा कि चेंज मॉडिफिकेशन करना है तो मॉडिफिकेशन उसमें हो रहा है। एक बहुत ही डिफरेंट तरीके का कोर्स डिजाइन किया गया है और आने वाला वर्जन बहुत ही इम्प्रूव्ड और इन्हांस्ड वर्जन होगा। तो एक तो यह है कि आज का आप गेट जो भी एनालिसिस स्टार्ट होने वाला है कंसर्न टीचर्स के साथ पूरा देखिए। कल आप अपने परफॉर्मेंस को एनालाइज करिए। फिर आपको लगता है कि किसी भी तरह का सपोर्ट चाहिए आपको नेक्स्ट आईएएस से या मेड इजी से, यू आर मोस्ट वेलकम। कन्वेंशनल प्रैक्टिस प्रोग्राम, उसके कोर्सेज भी स्टार्ट होंगे ईएस के बाद 1 मार्च के आसपास, और वो कोर्सेज ऑफलाइन और ऑनलाइन मोड में अवेलेबल होंगे। बहुत ही कॉन्सेप्चुअल क्लियरेंस के लिए अच्छे होते हैं वो कोर्सेज। और कई स्टूडेंट्स जो गेट में अच्छी रैंक नहीं ला पाए हैं, अगले साल के लिए उनको तैयारी करना है और कॉन्सेप्ट क्लियर करना है, तो कन्वेंशनल प्रैक्टिस प्रोग्राम इज द बेस्ट फॉर देम ऑल्सो। इंजीनियरिंग सर्विस के लिए तो चाहिए ही चाहिए, स्टेट एग्जाम्स के लिए भी वो यूजफुल है, एसएससी के लिए भी यूजफुल है, तो इसलिए उस कोर्स को भी आप कर सकते हैं। एंड मेड इजी इज योर इंस्टीट्यूट। तो अगर आप मेड इजी के स्टूडेंट रह चुके हैं, अगर आपका कोई सब्जेक्ट छूटा हुआ है, अगर आप क्लासरूम में थे, किसी जगह आपके सब्जेक्ट छूट चुके हैं या किसी वजह से छूट गए हैं, तो you are most welcome to come attend those areas, improve yourself. We want that you should be selected। तो जो भी हमसे जो भी सहयोग चाहिए वी आर विलिंग टू गिव यू। विश यू ऑल द बेस्ट, स्टे फॉर द नेक्स्ट सब्जेक्ट। सिग्नल एंड सिस्टम पहले स्टार्ट होगा, रोहित त्रिपाठी जी आएंगे, एंड देन वन बाय वन ऑल द टीचर्स विल टेक देयर डिस्कशन फॉरवर्ड। थैंक यू।
हेलो एवरीवन। तो गेट का एग्ज़ाम होपफुली आप लोगों का बहुत अच्छा गया होगा, अच्छी रैंक भी आपको आएगी, ज़रूर आएगी। और लेट स्टार्ट सॉल्विंग सब्जेक्ट सिग्नल एंड सिस्टम। माई सेल्फ रोहित त्रिपाठी और मेरे साथ है नवीन सर। हम दोनों मिलकर सिग्नल के क्वेश्चन अभी सॉल्व करने वाले हैं, और इसके बाद सारे सब्जेक्ट के क्वेश्चन वन बाय वन हम लोग अच्छी तरह से सॉल्व करेंगे, और आपके सारे जो डाउट्स होंगे वो आप लाइव सेशन में लिखिएगा, उसे हम लोग रिप्लाई भी करेंगे। ठीक है। सो फर्स्ट क्वेश्चन इज फॉर द गिवन कॉजल एलटीआई सिस्टम ट्रांसफर फंक्शन। तो बच्चों ट्रांसफर फंक्शन गिवन है, व्हाट इज द ट्रांसफर फंक्शन 2z स्क्वायर प्लस 3 अपॉन z प्लस 1/3 इंटू z माइनस 1/3। नाउ दिस क्वेश्चन इज MSQ, तो मैं यहाँ पर मेंशन कर देता हूँ, दिस क्वेश्चन इज MSQ। ओके, तो अभी देखिए इसमें क्या करना है, हमें फाइंड आउट करना है कौन कौन से ऑप्शंस इसमें करेक्ट हैं। So option A system is minimum phase, option B final value of impulse response is 0, then initial value of response is 2, system is stable and so on। ठीक है। तो सबसे पहले आप इसमें देखें कि इसका पोल लोकेशन किधर है। What are the pole locations and zero locations? Okay, so where are the zeros located? अब जीरो फाइंड आउट करना है तो न्यूमरेटर को किससे इक्वेट करना होगा, जीरो से। जब आप न्यूमरेटर को जीरो से इक्वेट करेंगे तो जीरो लोकेशन आप लिखते प्लस माइनस जे √3/2। ओके, तो बच्चों आप न्यूमरेटर को जीरो से इक्वेट करना, तो फिर z के जो वैल्यूज आएंगे वो इस सिस्टम के जीरोज होंगे, वो जीरोज मैंने वहां पर लोकेट कर दिए हैं, प्लस माइनस जे √3/2। अब इसके बाद पोल लोकेशंस अगर आप यहाँ से फाइंड आउट करें तो पोल लोकेशंस में क्या लिखता, प्लस माइनस 1/3। ठीक है, तो बच्चों डिनोमिनेटर को जीरो से इक्वेट कर दो, पोल लोकेशंस मिल जाएगा। अब इसके बाद क्या करना है, प्लीज ध्यान रखना, आपको जो जीरोज और पोल्स हैं उनके मैग्नीट्यूड फाइंड आउट करने हैं। तो अभी क्या करना होगा, जीरोज और पोल्स के मैग्नीट्यूड। सो व्हाट आर द मैग्नीट्यूड ऑफ पोल्स? So pole magnitudes are 1/3. Similarly, we have to find out magnitude of zeros. So what are the magnitude of zeros? Let us find out. यहाँ जो भी जीरो लोकेशन है इसका मैग्नीट्यूड कितना, इसका मैग्नीट्यूड होगा √3/2। ओके, अच्छा अब देखिए पहला ऑप्शन क्या है, सिस्टम इज मिनिमम फेज। ओके, तो मिनिमम फेज में हमने क्या देखा है कि मिनिमम फेज में जितने भी जीरोज हैं वो यूनिट सर्किल के इनसाइड होने चाहिए। तो सिस्टम के मिनिमम फेज होने के लिए सारे जीरोज किधर, यूनिट सर्किल के इनसाइड। अब आप अगर यहाँ पर देखें तो यहाँ जो जीरोज का लोकेशन है, मैग्नीट्यूड ऑफ जीरोज इज ग्रेटर देन 1, और अगर मैग्नीट्यूड ऑफ जीरोज ग्रेटर देन 1 है इसका मतलब जीरो किधर है, यूनिट सर्किल के आउटसाइड है। और अगर जीरो यूनिट सर्किल के आउटसाइड है तो क्या ये मिनिमम फेज सिस्टम है, बिल्कुल नहीं। तो ये कैसा है, नॉन मिनिमम फेज सिस्टम। सो व्हाट इज द नेचर ऑफ सिस्टम, नॉन मिनिमम फेज सिस्टम। नॉन मिनिमम फेज सिस्टम। इसका मतलब ऑप्शन ए क्या है? रॉन्ग। नाउ व्हाट अबाउट फाइनल वैल्यू फॉर द इम्पल्स रिस्पॉन्स? इसके लिए हमें क्या यूज करना पड़ेगा? फाइनल वैल्यू थ्योरम। ओके, तो फाइनल वैल्यू थ्योरम यूज करने के लिए, एफ वी टी को यूज करने के लिए, ओके, फाइनल वैल्यू थ्योरम को यूज करने के लिए हमें इस तरह बढ़ना पड़ेगा। h of infinite, what is h of an impulse response of system? h of infinite is final value of impulse response. इसके लिए क्या यूज करेंगे? फाइनल वैल्यू थ्योरम। लिमिट z टेंस टू 1 z माइनस 1 z माइनस 1 इंटू एच ऑफ z। ठीक है, ओके, चलिए इसमें आगे बढ़ते हैं। लिमिट z टेंस टू 1 z माइनस 1 इंटू एच ऑफ z। एच ऑफ जेड यहाँ पर लिखा गया है, सपोज हम लोग इसे लिख लेते हैं 2z स्क्वायर प्लस 3 अपॉन z प्लस 1/3 इंटू जेड माइनस 1/3। ठीक है, अब यहाँ जो भी हमने टर्म लिखा है इसमें z को कितना पुट करना है? 1। अब आप z को 1 पुट करेंगे तो ये जो फैक्टर है ये कितना हो जाएगा? 0। तो बताओ आप फाइनल वैल्यू कितना आया? 0। ओके, तो फाइनल वैल्यू है कितना? 0। अब आप देखिए ऑप्शन बी में क्या लिखा गया है? फाइनल वैल्यू ऑफ इम्पल्स रिस्पॉन्स इज 0। इट मींस ऑप्शन बी इज करेक्ट। नाउ व्हाट अबाउट ऑप्शन सी? ऑप्शन सी के लिए हमें क्या यूज करना पड़ेगा? इनिशियल वैल्यू थ्योरम। तो ऑप्शन बी के लिए हमें क्या यूज करना पड़ेगा? इनिशियल वैल्यू थ्योरम। तो इनिशियल वैल्यू थ्योरम यूज करते हैं। इनिशियल वैल्यू थ्योरम में एच एन का वैल्यू एन इक्वल टू 0 पर कैलकुलेट करना है। तो इसके लिए थ्योरम कुछ इस फॉर्म में है। लिमिट z टेंस टू इनफाइनाइट, लिमिट z टेंस टू इनफाइनाइट एच ऑफ z। बहुत आसान है। एच ऑफ जेड गिवन है, इसमें जेड को इनफाइनाइट पुट करो। आप अगर देखो न्यूमरेटर का ऑर्डर है 2, न्यूमरेटर का ऑर्डर मतलब जेड का हाईएस्ट पावर न्यूमरेटर में कितना है? 2, और जेड का हाईएस्ट पावर डिनोमिनेटर में कितना है? अगेन 2, क्योंकि जेड इंटू जेड आप क्या लिखते हैं? जेड स्क्वायर। तो न्यूमरेटर डिनोमिनेटर में ऑर्डर सेम है, तो जब आप जेड टेंस टू इनफाइनाइट पुट करेंगे तो आप लिखते हैं लिमिट जेड टेंस टू इनफाइनाइट 2z स्क्वायर अपॉन जेड स्क्वायर। क्योंकि बच्चों जेड से जेड मल्टीप्लाई होता है तो आप क्या लिखते हैं? जेड स्क्वायर। तो बेटा आप ऐसे ही तो लिखते हैं लिमिट z टेंस टू इनफाइनाइट 2z स्क्वायर अपॉन z स्क्वायर। तो z स्क्वायर विल बी कैंसिल्ड आउट, तो क्या रह जाता? 2। तो हमने देखा आंसर कितना आया? 2। तो इनिशियल वैल्यू हमने कैलकुलेट किया, इनिशियल वैल्यू कितना आया? 2। एंड फाइनली व्हाट अबाउट द सिस्टम स्टेबिलिटी? देखिए यहाँ पर इस क्वेश्चन में लिखा गया था सिस्टम का नेचर है कॉजल। तो सिस्टम का नेचर कैसा है? कॉजल। ओके, तो सिस्टम का नेचर कैसा है? कॉजल। इसको ध्यान दीजिए, कॉजल सिस्टम। और बेटा कॉजल सिस्टम की स्टेबिलिटी के लिए क्लास में बड़े डिटेल में डिस्कस किया है। कॉजल सिस्टम की स्टेबिलिटी के लिए पोल का मैग्नीट्यूड 1 से कम होना चाहिए, मतलब पोल का मैग्नीट्यूड 1 से कम है तो पोल यूनिट सर्किल के अंदर होगा। तो बताओ कॉजल सिस्टम कैसा? स्टेबल। अब आप देखो पोल का मैग्नीट्यूड कितना? 1/3। तो पोल का मैग्नीट्यूड 1 से क्या है? कम है, तो पोल किधर है? यूनिट सर्किल के इनसाइड है। इसका मतलब कंडीशन सेटिस्फाइड, सो दिस कॉजल सिस्टम इज स्टेबल। इनिशियल वैल्यू हमने कैलकुलेट किया था, मैच हो गया। तो आपने चेक किया यहाँ पर कौन कौन से ऑप्शंस, एक मिनट, यहाँ पर कौन कौन से ऑप्शंस मैच हुए? बी, सी एंड डी, क्योंकि सिस्टम भी स्टेबल है। तो करेक्ट ऑप्शंस हैं बी, सी एंड डी। ओके, डिफरेंट कलर से इसे लिख देता हूँ, हो सकता है ये आपको पता नहीं चल रहा होगा तो डार्क कलर से लिखता हूँ। ओके, एक बार फिर से बी, सी एंड डी, दिस 3 ऑप्शंस आर करेक्ट। तो करेक्ट ऑप्शंस हैं बी, सी एंड डी। अब इसके बाद नेक्स्ट क्वेश्चन की ओर चलते हैं। नेक्स्ट क्वेश्चन नवीन सर अभी एक्सप्लेन करने वाले हैं, तो बने रहिएगा, कहीं नहीं जाना आप लोगों को।
Hello students, we'll see the next question. So for the given x of t and y of t, two signals are given. The first one is x of t is given, and in terms of y of t we need to write it. And x of t and x of f Fourier transform, y of t Fourier transform is y of f is given in the question. So find y of f in terms of x of f. So to write y of f in terms of x of f, first of all represent x of t and in terms of the y of t given signal. So if you see that the x of t signal, that is, we can see the limits of x of t, that is present from -1, so -0.5 and 0, but here it is present as -2, 0 and 2. So first of all, we need to make it as the x of t by 4, the time scaling operation. So we can perform the time scaling operation. So performing the time scaling operation with x of t by 4. So when you perform x of t by 4, the sketch will present like this, that is t. So a value is equal to 1 by 4, which is the scaling factor value, and a value is equal to 1 by 4 will divide with all the limits. So as we study as in the classroom also. So minus 1 divided by 1 by 4. So this limit will present equal to that of 4. So this value is equal to that of minus 4, and it is minus 2. And here another limit, it is equal to 0 divided by 1 by 4, that is equal to 0 into 4 will become equal to 0. And the sketch will going to be present as shown in the figure, and this value is equal to that of minus 1. The amplitude value is minus 1, because we are performing time transformation, there is no change in the amplitude. So next we will perform that the sketch has to be shifted towards to the right side. So making towards to the right side, so we are performing x of t. So difference here minus 4 is there, but here requirement is minus 2. So what we are doing is t minus 2 upon 4. So when you perform t minus 2 upon 4, then what happened to the sketch is this entire sketch will shifted towards to the right side by 2 units. So therefore shifted towards the right side by 2 units. So this become equal to minus 2, and it is equal to 0. So minus 2, because minus 4 plus 2 is equal to minus 2, minus 2 plus 2 is 0, 0 plus 2 is equal to 2. So the sketch will shifted towards to the right side, and if you just observe this one, the relation between y of t and x of t minus 2 by 4, you find out that we need a time reversal, sorry, amplitude reversal is required. So when the amplitude reversal is done, so both will remain same. So that we can write like this, our y of t is equal to, writing like this, that is equal to minus of, so x of the value is equal to t minus 2 upon 4, and this is the value we are having. So for this we need to apply the Fourier transform. So apply Fourier transform. So once we apply the Fourier transform, you will get the required relation between y of f and x of f. So as usual we are performing the Fourier transform for this one. So y of f is equal to, so 4 scaling. So when we are performing the scaling, that is equal to 1 upon 1 by 4, it is present, and it is equal to x of f by 1 by 4, and because of the shift value we are writing like this, e to the power of minus j, the value is equal to 2 pi f, and the shift units are 2, because minus means become minus 2, and we are also having a minus sign. So that's a minus sign was indicating here, which is equal to the minus. So we rearrange this. So y of f value is equal to 4 goes upside, that become minus 4. So x of this value is equal to 4 into f, 4 goes upside, become 4 into f, and this value is equal to e to the power of minus j 4 pi f. If you cross check the options, so the option C is matching. So minus 4 x of 4f, e to the power of minus j 4 pi into f. So this question is already present in the workbook also, as we solve in the classroom. The same question is repeated in the GATE exam. Okay. So see the next question. So once we see the next question, it is given as a causal and stable LTI system with impulse response h of t produces output y of t for input x of t. A signal x of 0.5 into t is applied to another causal and stable LTI system with impulse response h of 0.5 into t. Output y of t is. See, if you find out the first system, causal and stable LTI system with impulse response h of t produces output y of t for input x of t. We know that for an LTI system, we always use the convolution as a mathematical tool, so that for the analysis of system, we can write like this. So representing in this way, that is y of t, the relation I am writing, that is x of t convolved with h of t. If you see that x of t convolved with h of t, and the another causal and stable LTI system, we are applying input x of 0.5 into t, means the input is going to be scaled by 0.5 times. So we can use the time scaling property. That means nothing but an x of 0.5 into t convolved with h of 0.5 into t. As we study the scaling property, x of at convolved with time scaling property, h of at is equal to, so 1 by mod A y of at. Already we see this property as time scaling, properties of convolution. In the same manner, in place of A, the constant we are having 0.5, that means in the y of t will also changes as 1 by 0.5 into y of 0.5 into t. This can also be written as 2 times, because 0.5, 1 by 0.5 means 2 times, y of 0.5 into t is equal to x of 0.5 into t convolved with h of 0.5 into t. So this is the answer, 2 into y of 0.5 into t. So the remaining questions will deal with the Rohit Tripathi sir.
ओके, थैंक यू नवीन सर। तो वापस से हम लोग चलते हैं और देखते हैं नेक्स्ट क्वेश्चन क्या है। सो नेक्स्ट क्वेश्चन इज वेरी इंटरेस्टिंग, और ये इंटरेस्टिंग क्वेश्चन देखना आप। y ऑफ n इज इक्वल टू डी एफ टी ऑफ डी एफ टी ऑफ डी एफ टी ऑफ डी एफ टी ऑफ एक्स ऑफ n। मैं भी बोलते बोलते थक गया, ठीक है। तो ध्यान रखिएगा, ये क्वेश्चन मैंने एज इट इज क्लास में कराया था, एंड और ये भी बोला था कि इट इज वन ऑफ द मोस्ट इंपॉर्टेंट क्वेश्चन फॉर द गेट पर्पस। ओके, क्लासरूम में, ऑफलाइन में, ऑनलाइन में ये सारे क्वेश्चन कराए हैं, ये क्वेश्चन स्पेशली मैंने कराया है। अच्छा, इसमें अगर देखें तो इसमें हमें y ऑफ n n इक्वल टू 0 पर कैलकुलेट करना है। तो दोस्तों इसमें ट्रिक क्या है थोड़ा देखना आप। लाइक x ऑफ n, अब देखो 4 टाइम्स DFT है, 4 टाइम्स DFT है, तो इसे 2 पार्ट में डिवाइड करो। फर्स्ट अटेम्प्ट में क्या करो, 2 टाइम्स DFT, फिर इसके बाद नेक्स्ट अटेम्प्ट में क्या करना, फिर से 2 टाइम्स DFT। तो 2 + 2 कितने टाइम्स हो गया, 4 टाइम्स हो गया। तो हम लोग क्या करेंगे, 2 टाइम्स DFT अभी हमें अप्लाई करना है। तो कौन सी प्रॉपर्टी मैं यूज कर रहा हूं, बोलो, ड्यूअलिटी। ओके, तो ड्यूअलिटी प्रॉपर्टी मैं यूज कर रहा हूं, और ड्यूअलिटी प्रॉपर्टी के अकॉर्डिंग ऐसे बढ़ना है। n, व्हाट इज n, n पॉइंट DFT वाला n। तो यहाँ n की वैल्यू आप देखो कितने सैंपल्स हैं, 4। तो n की वैल्यू कितनी है, 4 है। तो n पॉइंट DFT में n की वैल्यू कितनी है, 4। सो n इंटू एक्स ऑफ माइनस n, ओके, विथ मॉड n ऑपरेशन। ओके, अच्छा, अब इसके बाद इस पे फिर से 2 टाइम्स क्या अप्लाई करना है, DFT। इस पर हमें 2 टाइम्स DFT फिर से क्या करना है, अप्लाई। तो फंडा क्या है कि जब आप ड्यूअलिटी अप्लाई करेंगे तो 2 टाइम्स DFT अप्लाई होगा, और जब ड्यूअलिटी अप्लाई होगा मतलब 2 टाइम्स DFT अप्लाई होगा, तो सिग्नल को फोल्ड करो और n पॉइंट वाले n से मल्टीप्लाई कर दो। सेम फंडा इधर भी करना है। हमें क्या करना है, यहाँ जो भी सिग्नल है इसे क्या करना है, फोल्ड करना है। ओके, फोल्डिंग। तो फोल्डिंग करने का मतलब n इंटू एक्स ऑफ माइनस n। अब n इंटू एक्स ऑफ माइनस n क्या, n इंटू एक्स ऑफ n। ओके, अच्छा, अब फोल्ड करने के बाद किससे मल्टीप्लाई करना, n से। तो यहाँ फिर से किससे मल्टीप्लाई करोगे, n से। तो हमने लिखा क्या, n स्क्वायर इंटू एक्स ऑफ n। और दोस्तों यही किसके इक्वल है, y ऑफ n के इक्वल है, बिकॉज y ऑफ n इज 4 टाइम्स DFT ऑन x ऑफ n। तो हमने y ऑफ n फाइंड आउट कर लिया। सो y ऑफ n मैंने यहां पर लिखा है, इसको दोस्तों आप ध्यान से देखिए, y ऑफ n इज इक्वल टू n स्क्वायर एक्स ऑफ n। अब इसमें n को क्या पुट करना है, 0। तो जब आप यहां पर n को 0 पुट करेंगे तो x ऑफ n में भी n को क्या पुट करेंगे, 0। तो आप क्या लिखते, y ऑफ 0 विल बी इक्वल टू n स्क्वायर एक्स ऑफ 0। ओके, अब अगर x ऑफ 0 की वैल्यू देखें तो कितनी है, 0। तो x ऑफ n इक्वल टू 0 पर कितना है, 0। अब 0 से किसी भी वैल्यू को मल्टीप्लाई करें तो आप बताइए रिजल्ट कितना आएगा, 0। तो इस क्वेश्चन का आंसर क्या होना चाहिए, 0। ओके, तो ये बहुत ही ट्रिकी क्वेश्चन था। जिनको ये ट्रिक आता है उनके लिए सुपर इजी है, और ये सुपर इजी ट्रिक मैंने सिग्नल सिस्टम की क्लास में डिटेल में डिस्कस किया है। आई होप जिन्होंने क्लासेस अटेंड की होगी उन्हें बहुत फायदा हुआ होगा। चलिए आगे बढ़ते हैं, नेक्स्ट क्वेश्चन देखते हैं। ओके, नेक्स्ट क्वेश्चन, इट इज वन ऑफ द मोस्ट ट्रिकीस्ट क्वेश्चन ऑफ सिग्नल एंड सिस्टम। इसमें हमें पहचानना है कि हमें प्रोसीड कैसे करना है, ध्यान से पढ़ना। सो व्हाट इज सिस्टम इनपुट, 2 cos 38 pi t प्लस पाई बाई 3। पहला काम, इनपुट का फ्रीक्वेंसी चेक कर लो कितना है। सो व्हाट इज द वैल्यू ऑफ ओमेगा नॉट, 38 पाई। ओके, ये मैंने लिखा है रेडियन पर सेकेंड में। ओके, अब इस इनपुट को किस पर अप्लाई करना है, LTI सिस्टम पर। इस LTI सिस्टम का क्या गिवन है, इम्पल्स रेस्पॉन्स। ओके, इस इम्पल्स रिस्पॉन्स में थोड़ा करेक्शन करना है, वो मैं फटाफट करेक्शन करता हूँ और आपको बताता हूँ वो करेक्शन क्या है, क्योंकि ये क्वेश्चन मेमोरी बेस्ड है तो इसमें कुछ करेक्शन भी करना था। वो करेक्शन मैं इधर करके इसमें लिख रहा हूँ। बेटा इसको क्या करना है, करेक्ट। और जो एक्चुअल इम्पल्स रेस्पॉन्स है वो कुछ ऐसा है, एच ऑफ टी इज इक्वल टू साइन 2 पाई टी अपॉन पाई टी इंटू कॉस 38 पाई टी माइनस पाई बाई 3। तो इसमें थोड़ा सा करेक्शन करना था तो करेक्ट करके मैंने यहाँ पर अभी इसे लिख दिया है। चलिए, तो सिस्टम का इम्पल्स रिस्पॉन्स गिवन है और हमें क्या करना है, सिस्टम का आउटपुट वाई टी कैलकुलेट करना है। ओके, ध्यान से देखो, यहाँ जो इम्पल्स रिस्पॉन्स है, इस इम्पल्स रिस्पॉन्स में हम लोग क्या करेंगे, किसी भी तरह एच ऑफ ओमेगा फाइंड आउट करेंगे। फिर एच ऑफ ओमेगा फाइंड आउट करने के बाद पहले चेक करेंगे कि एच ऑफ ओमेगा के पास बैंड रीजन में ये जो इनपुट फ्रीक्वेंसी है ये लाई कर रहा है कि नहीं। अगर लाई करेगा तो फिर न्यूमेरिकल कैलकुलेशन करेंगे और अगर लाई नहीं करेगा तो फिर सिस्टम का आउटपुट कितना, 0। ओके, तो एच ऑफ टी में इसमें जो फर्स्ट टर्म है यहां पर जो है, पहले इसका मैं क्या ड्रॉ करूंगा, फूरियर ट्रांसफॉर्म। अगर इसका फूरियर ट्रांसफॉर्म ड्रॉ करूं ओमेगा के अगेंस्ट, तो ये साइन बी टी अपॉन पाई टी का फॉर्म है और साइन बी टी अपॉन पाई टी का फूरियर रेक्टेंगुलर मिलता है। तो इसका फूरियर बेटा कैसा होगा, रेक्टेंगुलर। एक्सटेंशन माइनस बी से बी तक, यहाँ बी की वैल्यू कितनी है, 2 पाई, तो एक्सटेंशन माइनस 2 पाई से 2 पाई तक, एम्पलीट्यूड कितना, 1। अब एक चीज ध्यान देना, ये किससे मल्टीप्लाई हुआ, साइनोसाइड से। साइनोसाइड में फेज कितना, अभी हमें उससे मतलब नहीं है, हमें मतलब किससे है, साइनोसाइड के फ्रीक्वेंसी से। तो साइनोसाइड की फ्रीक्वेंसी कितनी है, 38 पाई। तो अभी हम लोग कौन सा प्रॉपर्टी यूज करेंगे, फूरियर ट्रांसफॉर्म का प्रॉपर्टी ऑफ मॉड्यूलेशन। ठीक है, क्लास में डिटेल में बताया प्रॉपर्टी ऑफ मॉड्यूलेशन। जब आप किसी सिग्नल को आप साइन या कॉस से मल्टीप्लाई करते हैं तो इसके स्पेक्ट्रम को ओमेगा नॉट से, यहाँ पर फ्रीक्वेंसी कितनी है, 38 पाई, तो 38 पाई से राइट शिफ्ट करो, फिर इस स्पेक्ट्रम को 38 पाई से लेफ्ट शिफ्ट करो। दिस इज अबाउट द मैग्नीट्यूड ऑफ स्पेक्ट्रम। ओके, मैं अभी फेज में इन्वॉल्व नहीं हो रहा हूं, अभी मैं मैग्नीट्यूड की बात कर रहा हूं। तो बेटा एच ऑफ टी का फूरियर ट्रांसफॉर्म सपोज एच ऑफ ओमेगा है और हमें क्या ड्रॉ करना है, मैग्नीट्यूड। हमें क्या ड्रॉ करना है, मैग्नीट्यूड। और मैग्नीट्यूड ड्रॉ करना है तो कैसे ड्रॉ करेंगे, ये जो फर्स्ट वाला टर्म है इसका जो भी फूरियर है इसे 38 पाई से राइट शिफ्ट। अच्छा, 38 पाई से पहले क्या करोगे, राइट शिफ्ट। तो 38 पाई से राइट शिफ्ट करोगे तो 38 प्लस 2 कितना, 40 पाई, और 38 माइनस 2 कितना होगा, 36 पाई। सिमिलरली फिर 38 पाई से क्या करेंगे, लेफ्ट शिफ्ट। तो बेटा लेफ्ट शिफ्ट करोगे तो यही फ्रीक्वेंसीज आएंगे नेगेटिव साइन के साथ। ओके, एंड वी आर नॉट इंटरेस्टेड अबाउट एम्पलीट्यूड। अभी हम लोग इंटरेस्टेड नहीं है एम्पलीट्यूड में, क्योंकि हमें देखना है कि ये जो फिल्टर के ट्रांसफर फंक्शन का मैग्नीट्यूड है इसके अकॉर्डिंग इसका पास बैंड रेंज क्या है। आप अगर देखें तो ये एक बैंड पास फिल्टर है। बेटा ये कौन सा फिल्टर, बैंड पास फिल्टर। इसमें लोअर कट ऑफ फ्रीक्वेंसी कितनी, 36 पाई, अपर कट ऑफ फ्रीक्वेंसी कितनी, 40 पाई। तो ये पास करेगा 36 पाई से 40 पाई रेडियन पर सेकेंड का इनपुट। ओके, ना व्हाट अबाउट इनपुट, ध्यान से देखना बेटा, यही यहाँ पर गेम चेंजर है। यहाँ पर इनपुट की फ्रीक्वेंसी कितनी, 38 पाई। यहाँ इनपुट की फ्रीक्वेंसी कितनी है, यहाँ इनपुट की फ्रीक्वेंसी कितनी है, 38 पाई। ओके, इनपुट की फ्रीक्वेंसी 38 पाई है और ये इस फ्रीक्वेंसी रेंज में क्या कर रहा है, लाई कर रहा है। एक मिनट, मैं एक बार इनपुट फ्रीक्वेंसी भी चेक कर लूं। इनपुट की फ्रीक्वेंसी 4 पाई टी प्लस पाई बाई 3 है। इस क्वेश्चन में यहां भी करेक्शन करना है। इस क्वेश्चन में इधर भी करेक्शन करना है। यहाँ करेक्शन क्या है मैं बता रहा हूँ। यहाँ जो इनपुट की फ्रीक्वेंसी है, दिस फ्रीक्वेंसी इज 4 पाई टी प्लस पाई बाई 3, मतलब यहाँ पर ये जो टर्म है इस टर्म की जगह इधर फ्रीक्वेंसी कितनी है, 4 पाई। और ये जो टर्म है इसकी फ्रीक्वेंसी कितनी है, फिर 4 पाई। ओके, तो अगर हम लोग देखें तो एक्स ऑफ टी में जो फ्रीक्वेंसी है कितनी है, 4 पाई। दिस वाज नॉट 38 पाई, क्वेश्चन में कुछ प्रिंटिंग मिस्टेक था तो वो मैंने अभी करेक्ट कर दिया है। तो यहाँ जो साइनोसाइड है इसमें फ्रीक्वेंसी कितनी, 4 पाई। जिस सिस्टम की हम लोग बात कर रहे हैं बैंड पास फिल्टर है, इसका पास बैंड रेंज कितना है, 36 पाई से 40 पाई। तो क्या इसके पास बैंड रेंज में इनपुट लाई कर रहा है, बिल्कुल नहीं, क्योंकि इनपुट की फ्रीक्वेंसी कितनी है, 4 पाई। तो क्या ये इस सिस्टम से पास होगा, बिल्कुल नहीं। तो सिस्टम का आउटपुट मैं फिर क्या लिखूंगा, आप खुद सोचो। सिस्टम का आउटपुट बाय टी मैं क्या लिखूंगा, 0। रीजन मैंने बता दिया, बैंड पास फिल्टर है, इसके पास बैंड रेंज में इनपुट लाई नहीं कर रहा है, तो इसके लिए सिस्टम का आउटपुट कितना, 0। ओके, तो चलिए अब इसके बाद सिग्नल सिस्टम के सब्जेक्ट, इसके क्वेश्चंस कंप्लीट हो गए। अब थोड़ी देर के बाद नेक्स्ट सब्जेक्ट के क्वेश्चंस हम लोग कंटिन्यू करेंगे।
Hello everyone. Let's now take up control system questions and the memory based control system questions and their solutions. So, the first question is 40 dB per decade rate of change of slope in the board plot is equal to which of the following? That's a very simple and familiar question. 6 decibel per octave, 6 decibel per octave and 20 decibel per decade are equivalent. If the frequency changes 10 times, then the magnitude changes by 20 decibel, which is as good as if the frequency changes by 2 times called octave, then that is equal to 6 decibel per octave. So now when this figure gets doubled, 20 that is becoming 40, then 6 becomes 12. That simple is the question. And we did this many times during prelims preparation, gate preparation, mains preparation. It's a very common thing that we say hundreds of times. So, I mean, it should not take more than a second to, it's just to mark the answer, that's it. It should be 12 dB per octave. Right, so answer to the question is option A. In this question, G of S, it's a block given here whose value is equal to 1 by S square. You can take it to be a controller block, a double integrator controller it is. It's an integral controller but double integrator. And a plant whose transfer function k s plus alpha upon s plus 4. Question is, if the closed loop poles of the system are located at -1 plus r minus j root 3, then find the value of this unknown parameter alpha. For this, first of all, we need to form the characteristic equation. We need to form the characteristic equation which comprises of this controller and this plant with the feedback which is negative 1 plus 1 upon s square multiplied with k s plus alpha upon s plus 4. is equal to 0. From this, the characteristic equation of the system becomes s cube plus 4so square plus ks plus alpha k is equal to 0. Now, these are the complex poles which are dominant. This system being third order. In a third order system, first order and second order, both the components are present, but first order is always ordinary, second order being dominant. These are the dominant complex poles. Let the first order pole be denoted with s plus x. Let the first order be x multiplied with this dominant poles, which is s square plus 2s plus 4. Now all that we need to do is multiply these two and make it cubic polynomial and compare the coefficients. You're going to get this value of alpha to be 1 upon comparison. We have got three unknowns. One is x, second is k, third is alpha, and we will get three equations. By comparing and simplifying, we get the value of alpha to be 1. Answer to the question is option B. In this question, consider the feedback control system shown. E is the error signal. This system has got unity feedback, and the plant function given is 6 upon s plus 1 s plus 2. If the input is unit step, then E of t will become equal to what? This is the open loop transfer function of the system. See, if the options includes all four value based, if they are saying like error will be 1 by 3, this is steady state error to infinity. Steady state error is 1 by 3, 1 by 4, 0 and some other option, then we never have to doubt the stability of the system. We don't have to check the stability of the system if the steady state errors are given to be finite values, 0 or finite or infinite. But if any question says that does not exist, not possible, none of the above, then we first have to explore the stability of the system, then only we can answer to this, because entire response analysis is applicable only for stable system. Anything that you talk, not just steady state error, anything that you talk about in the response analysis, either in time domain or frequency domain, is valid if and only if the system is stable. So if any such option exists that not possible, none of the above, cannot be determined, then we first have to explore the stability while answering to any question of response analysis. And if the system is found to be stable, then we neglect that option and we look for the other things based on formula. So formula comes in the second place, stability comes in the first place for anything in the response analysis. Since I see an option like it does not exist because E of t is oscillatory, something like this, it's not about that E of t is oscillatory. Oscillations are not for a signal, for the response of a system, it's about a system. This is G of S, the plant. Then the characteristic equation of this system, can be obtained as s cube plus 3s square plus 2s plus 6 is equal to 0. In third order system, product of inner coefficients and product of outer coefficients, if you check, this is equal. If I say this is A, B, C and D, if B into C is equals to A into D, then this system is marginally stable. This is marginally stable. This system is not stable, which means that this steady state error does not exist because the system is oscillatory. Moving to the next question. Consider the state space representation of a system. Find the transfer function of the system. See, one formula to find the transfer function from the state model is C S I minus A inverse into B plus D. But that becomes very lengthy. By the time you find Si minus A and then form the inverse and then multiply with B, then multiply with C, then add D. This is A matrix, this is B matrix, this is C matrix. And I taught you this shortcut many times. There are plenty of shortcuts that we studied, unlimited number of shortcuts. Not just here, in GTQ, in class, in test series, in all the places you might have seen unlimited number of shortcuts, the easy way of doing things, which are going to save a lot of time, controllable form. Then these are going to be the coefficients of the characteristic equation. This is going to be the gain of the system. These are going to be the these are going to be coefficients of the denominator polynomial, which we call it to be characteristic polynomial. These are coefficients of the numerator polynomial. And you have to take them in this order, but write in the transfer function in the reverse order. Take them in this order, write them in the reverse order. Like the transfer function can directly be written like this. Highest power of s coefficient being 1. Now, you have to take them in this direction, but write in the opposite direction with the sign changes. If it is minus 2 minus 3, we take it to be 2 and 3. So this is going to be s square plus 3s plus 2. Read in this direction, write in this direction. What about the numerator polynomial coefficients? Read in this direction, write in this direction without sign changes. Without sign changes. As far as C matrix is concerned, you should not change the sign of the coefficients. As far as the A matrix is concerned, you have to do that. So read it to be minus 2 minus 3, write it to be 2 and 3. Read it to be minus 2 minus 5, write it to be minus 2 minus 5. And gain of the system is 1, that becomes a multiplier here. D is anyway 0, that's the transfer function of the system. As far as the data is concerned. Yeah, this question.
Thank you, sir. As all the questions from the control system subject we have discussed, and they all were very easy. When we discuss this question here, something is coming in the sense with respect to our classroom notes, our discussion, means in the variety of the questions possible we have already covered. For example, if we observe here one of the line here, as we observe the one of the line that faster than e minus t. So similar type of the case we have mentioned during the class. एग्जामिनर किस तरह से ओरिजिन को शिफ्ट कर सकता है कि हमने लगभग 5 केसेस बताए थे, लैंग्वेज बताए थे जिसके बेस्ड पर क्वेश्चन आ सकते हैं। उसमें से एक यह लैंग्वेज थी। किस तरह से एग्जामिनर चाहे तो अपने रेफरेंस ऑफ कॉन्सेप्ट की ओरिजिन को कैसे शिफ्ट करना बता सकता है। तो चलिए क्वेश्चन को देखते हैं। क्वेश्चन क्या कह रहा है, ये पर्टिकुलर क्वेश्चन दिया हुआ है, हमें जीएस दिया हुआ है, एंड फाइंड के सो दैट द impulse response of the closed loop system decays faster. This language was used in our notes as well कि किस तरह से आपका एग्जामिनर आपको ओरिजिन शिफ्ट करने के कॉन्सेप्ट के लिए इंट्रोड्यूस करता है, आइडिया देता है। तो सबसे पहले हम तो यहाँ पर कैरेक्टरिस्टिक्स इक्वेशन लिखना चाहेंगे। अब कैरेक्टरिस्टिक इक्वेशन क्या हो जाएगा, 1 प्लस जी एस एच एस इक्वल टू 0, जहां पे एच एस क्या है 1 है, जी एस हमें दिया हुआ है। सो डेफिनेटली इट इज गोइंग टू बी व्हाट एस प्लस 1 इंटू s plus 2 into s plus 3 plus k is equal to 0। अब जैसा कि हम जानते हैं कि हमें विद रिस्पेक्ट टू ओरिजिन नहीं देखना है, हमें देखना है कि आपका e पावर माइनस टी के रिस्पेक्ट में ये -1 लोकेशन हुआ, हमें e पावर माइनस टी के रिस्पेक्ट में हमें क्या चाहिए, पावर मस्ट बी greater negative, means we want to observe the condition for k that the pole must lie in the left hand side of the -1। अगर हम क्वेश्चन के लैंग्वेज को अच्छे से क्लास में समझे हुए हैं तो सीधे हमें क्या करना है, ज्यादा टाइम ना वेस्ट करते हुए एग्जामिनेशन के दौरान सीधे हमें x(s-1) पुट करके इक्वेशन को फिर से रिफ्रेम करना है। और जब हम इक्वेशन को फिर से रिफ्रेम कर रहे हैं तो हमें जो इक्वेशन मिल रही है वो है h⁻³ plus 2s square plus s plus k is equal to 0। s cube plus 3, it's 3s square plus 2s plus k. This will be the equation we are getting after solving by putting s equal to s-1। And now when we are going to use the Routh-Hurwitz table, अब हमें क्या करना है, यूज करना है Routh-Hurwitz टेबल और पता करना है कि वो रेंज ऑफ k क्या है जिसके रिस्पेक्ट में इस इक्वेशन के रूट्स कहां पर विद रिस्पेक्ट टू दैट s। अगर हम बात करें अब हमारा क्या हो गया, ये s डैश हो गया, इसके लेफ्ट हैंड साइड में आए तो हमें जो रेंज पता चल रही है विद रिस्पेक्ट टू Routh-Hurwitz 0 to 6 हमें सॉल्यूशन में मिल रहा है। और अब हम सुटेबल ऑप्शन को ऑब्जर्व करेंगे। सो फॉर दिस पर्टिकुलर रेंज वी कैन से यस इट इज गोइंग टू सेटिस्फाई व्हाट 1 greater than equal to k and then less than equal to 5। Like this, if we observe, the D option is going to be well suited for this particular range, means within second we can solve this if we have good idea how to apply this concept with respect to the different language. Examiner can introduce this idea in our question. So the answer of this particular question is D. Thank you.
Good evening, dear students. This year 4 questions have been asked from the network analysis. One is from the two-port network, transients, theorems and the basics. But out of these questions, 2 questions are very easy, but the 2 questions are the moderate. Come to this one. For this example, what is our requirement is Ix. You can go for the any technique. Now I am going for the super node technique. Now for this example, let us assume node voltage of this one V1, node voltage is a V2, node voltage is a V2. With respect to ground potential, what the polarity of this one is a plus. What the polarity of this one is a plus. With respect to the super node technique, equation is combinedly developed. With respect to super node technique, equation combinedly developed for the node 1 and node 2, excluding voltage source, excluding voltage source. Now for this example, 5 milliamperes is the incoming current. Now corresponds example V1 by 1 kilo ohm, V1 by 1 kilo ohm is the outgoing current. V1 by 1 kilo ohm resistor. Now corresponds example we write this in the V2 by 1 kilo ohm resistor. What about the 2 milliamperes? 2 milliamperes also outgoing. If I write this side here, 2 milliamperes I get the negative sign. Now can you simplify this equation? आप इधर simplify किया तो we can write this as a V1 plus V2. देखो जी आप इधर simplify किया तो V1 plus V2 is equal to 3. V1 plus V2 equal to 3. Now come to the second equation. Now in this one here, second equation, wherever the positive is connected, the corresponding voltage is a higher potential. We can write this as a V2 minus V1, V2 minus V1, V2 minus V1 equal to, we can write this as a 1000 I naught. Okay, in this one 3 unknowns are there, one is the V1, V2, other one is the I naught. Now let us eliminate the I naught value. To eliminate the I naught value, I naught is a, as per given data, I naught is the current of this branch, I naught is the current of this branch. We can write this with a V1 by 1 kilo ohm, V1 by 1 kilo ohm. Can you simplify this entire equation? If you simplify this one, we can write this with V2 equal to 2V1. मगर finally क्या चाहिए आपको Ix. Ix निकालने के लिए our main focus on the node 2 voltage. If you rearrange this equation from this one, we can write this V1 equal to V2 by 2. V1 equal to V2 by 2. Then if you substitute here, in place of V1, you can write the V2 by 2. इधर simplify करने से we get the V2 is equal to 2 volts. V2 equal to 2 volts. Now finally क्या चाहिए आपको Ix. क्या चाहिए आपको Ix. Now as per given information, Ix is the current of this branch. Ix is the current of this branch. Now V2 by 1 kilo ohm. Now what is the V2 equal to 2 volts? इधर simplify करने से what is the Ix equal to 2 milliamperes. Ix equal to 2 milliamperes. Okay, I hope all of you got the answer for this question. Come to the next one. In this example, what is the requirement is the time constant. It is very easy question. While finding time constant, what is the procedure? Deactivate all the independent sources. In this example, current source is given. Now current source is replaced by the open circuit. We have to deactivate this one. It is the open circuited. And always this time constant calculated after operating switch. देखिए example में arrow mark के ऊपर बहुत ध्यान रखना इधर. Arrow mark is the downwards. Now time constant after operating switch बोलता switch is closed. Now deactivated and as well as switch is closed. Then here we should separate the group of resistors and group of inductors. Group of resistors and group of inductors. Then in this example, if you read out this figure, here, we can indicate like this. Current source is deactivated and switch is operated. And in this example, we should select the AB point such that we should separate the group of resistors and group of inductors. With respect to AB, if you observe carefully, this 4 and 4 both are connected in the parallel. Equivalent resistance is the 2 ohms. These 2 ohms and 2 ohms both are connected in the series. then the total equivalent resistance. The total equivalent resistance is equal to 4 ohms. Now what is our requirement of the time constant? Time constant is a L by R equivalent. Because the example may only one inductor was given. Now we can reduce to 3 by 4 seconds. Okay. Remaining two questions will be explained by the Naresh sir.
Thank you, sir. Good evening, dear students. The question number is remaining two questions. One question is from the maximum power transformation theorem. Here asking question is, what is the value of RL such that the maximum power is transferred to the load? So very simple, that is RL is equal to RH hona chahiye, that is the value is RL is equal to RTH hona chahiye. Simple. How to find RTH when our dependent sources are present in the network? Either use V by I ratio or RTH is equal to VTH by ISC. I am using here V by I ratio concept. In place of RL, I just connect a voltage source or a current source and inactive the voltage source. Inactive means voltage source replaced by short circuit. Now I redraw the circuit, similar. Here is a dependent voltage source, resistance, here resistance and resistance. I am replaced with a short circuit, connect a voltage source V. This is a 1 volt or a 10 volts or 100, that is your choice. Here minus plus Vx, so 2 ohms, here 3 ohms, here minus plus Vx, here 3 ohms and 2 ohms. What the current is coming from this voltage source? V by I ratio. RTH is equal to V by I. Just I am applying a KCL here for finding the current. Here the ground 0 volts, here the V, this current is outgoing, I am assuming. Here the 0 volts, I incoming current is equal to V minus Vx by 2. This is outgoing current. Again, this is what the current is here flowing through this branch is V by 5. What is the Vx? Our intention is only the equation is in terms of V by I, where is the Vx is equal to, where Vx is equal to voltage across 3 ohms. The current is flowing here, entering is plus, leaving is minus. So Vx is equal to V by 5. The current is flowing is V by 5 into 3. This 3V by 5. Substitute in a first equation, that is I is equal to V minus Vx is 3V by 5 upon 2 plus V by 5. Simplify it, you get a V by I is equal to 2.5 ohms. So RTH is equal to 2.5 ohms. So RL value is equal to 2.5. ये पूरा करने की भी जरूरत नहीं है, डायरेक्टली इधर देख सकते हैं. So what is the shortcut for this one is? Shortcut method for this, here is a 2 ohms, here say 2 ohms is there. These two are in parallel. Both are in parallel means voltage is same. Here 3 ohms Vx, here also Vx is there. This Vx can be replaced by 3 ohms is possible. So once your 3 ohms, 2 plus 3 is 5 ohms, 2 plus 3 is 5 ohms, 5 in parallel, this is 2.5 ohms. Directly you can get an answer from this shortcut method. Okay. Next, this is from the 2-port network. You are asking the question. The question is Y21. What a Y21 is equal to? Y21 is equal to I2 by V1, providing V2 is equal to 0. V2 is equal to 0 means here short circuit the 2 dash port. Now write a equation here. I am writing equation only. This current is I2 is flowing here now. I2. Here is I1 is flowing. If you write a KVL equation in this loop, V2 is equal to 0 I am writing KVL equation here now. 4 into I1 plus I2 is equal to 8V1 in this loop. Now 4I1 plus 4I2 is equal to 8V1. Now second, if you write KVL equation in this loop, otherwise this loop, directly you can eliminate I1 from this one, I2 by V1. So V1 is equal to 2I1. Substitute 2 in 1, you get a Y21 is equal to 3 by 2, that is 1.5 Siemens. The answer for this question is 1.5 Siemens. Just to writing a 2 equations, get a answer. Okay, thank you.
Hello students, welcome to the digital electronics session. Hope you did very well the digital electronics questions. Why? Because what we discussed in the classroom and even in the PVQs of Made Easy, those type of questions only, those model questions only you got it. So let me explain such type of question here, where this is the question related to the essential prime implicants. You know, essential prime implicant is that particular prime implicant where it should have at least a single one having the chance of only one time grouping. So based on that particular definition, we should make the solution of this one. Of course, this is the K-map. First we should make it. Okay, in the case of K-map, right, first of all 4 variable K-map we are going to make here. A bar, B bar, this is A bar B, this is AB, this is AB bar, C bar, D bar, C bar D, CD, CD bar. Yeah, given the numbers are 0, 2, 5, 7, we just identify them 0, 2, 5, 7 and 8, 10, 8, 10. Next 12, 13, 14, 15. 12, 13, 14, 15. Let me make the grouping of all these, this corners one, where that is going to be the B bar, D bar, and this particular thing if you can make that one as BD. So of course this is also a group, but in this one is able to get the grouping with this in this quad, and this one is able to get the group even in this also, and this one is able to get the grouping in this quad, and it can also become in this particular side quad. That's why it is only prime implicant, that is AB is only prime implicant, but this BD is the essential prime implicant, and B bar D bar is also essential prime implicant. Why? Because here in these 4 ones we are able to get here a 1 in such a way that it is able to get the grouping only one time. Even this one is also like that, it is able to get the grouping only one time. That means essential prime implicant, for that we know in that particular group at least we should have a single one in such a way that it should have the chance of grouping only one time. And here we are having in this particular quad, this one is eligible to say this particular quad as API, and this one is also we are having the eligibility for that one also to say it is essential prime implicant. And as far as this particular quad is concerned, in that one these two ones are in that way that they are able to get only one time grouping chance. That's why those two based we are in need of at least one which is having a chance of only one time grouping. Of course here this one or based on that one we can say it is the essential prime implicant. Sir, but I am having a doubt, what about this one? Why it is not essential prime implicant, it is only prime implicant? Why? Why? Because here in these 4 ones, here you see this one, everyone is engaged more than one time in the grouping. See this one, it is having the chance of grouping in this quad and also in this quad, and this one is also having the chance of grouping in this quad and also in this quad. So what about this one? Yeah, this is having a chance of grouping in that quad, and also if you make like this a group, in that also it is able to get the grouping. No, like that this one is also having a chance of getting the grouping like this, and even also this side group quad. So when there is a chance of getting the grouping more than one time, and that particular one is not eligible to define that particular group as essential prime implicant, that's why we will say that only this B bar D bar and BD, these are essential prime implicants. Got it? Right. Next, if you see this one, this is the question. Always we used to say synchronous counters related question is definitely you are going to get that. So like that only here we are having, this is the sequential circuit of the synchronous counter. Sir, how we can say synchronous counter? See, this and this, both these two are connected from the same clock generator. When both are connected from the same clock generator, definitely that is nothing but the synchronous counter only. And we already defined a procedure to solve synchronous counter questions. What is the way that? First you should make a table like this. This one we are having like this. Yeah, this is T1 and here this is T0. Sir, what is T1, T0? Yeah, here this is nothing but the T1, this is nothing but T0. If you define like that, we are going to have T1, T0, and here this is Q1 and Q0, and this is the clock. And initially you just keep the 0, 0 by default, but first we should put here from where we are having the connections. For T1 we are having a connection from Q1 and also Q0 bar. So Q1 plus Q0 bar. And what about T0? T0 is having a connection from Q0 and Q1. This is Q1 plus Q0. So like that. Now if you observe here, you apply these conditions here. Q1 plus Q0. Initially we kept 0, 0. So that 0 plus 0 bar, that is 1 here, and Q1 plus Q0, that is nothing but 0 here. Toggle mode operation, 1 it is there, then 0 will change to 1, and 0 means no change, so 0 will be 0 here. Next again you should apply these conditions here. Q1 is nothing but here it is 1, and Q0 bar is nothing but 0 bar, again here it is 1, and here Q1 plus Q0 it is 1. So toggle condition, so 1 means 1 will going to make as 0, and this 1 toggle, that's why 0 will change as 1. Next again if you apply Q1 plus Q0 bar, 0 plus 1 bar, that is 0 here, 0 there we are having, and here q1 plus q naught, this is 1. So 0 means no change, 1 means toggle 0. So it is repeated, unrepeated, these 3 we got, so that is nothing but 0 0 1 0 0 1 0 0 like that. So this is the way we are able to get the answer for the synchronous counters. Got it? Right. Let me say the next question here. Here, this is a multiplexer question. As usual, always this is the important thing. Multiplexer, essential prime implicants and synchronous counter, these always we are going to expect the questions from these. Like that only we got another question here. And here if you observe the thing, it is so easy to solve. They said S should be 1 here. 1 means when you keep the 1 here, what happens? It should be selected. Okay, initially keep here as 0, that 0 will be here, so the 1 will be here. Next we are going to get the 1 here. Next that one is going to now comes here, by the NOT gate it will be 0, so that 0 here. So that 1 pulse for one operation they said it is 10 nanoseconds, and here also 10 nanoseconds. So here TC is nothing but 10 plus 10, this is nothing but 20 nanoseconds, and based on that if you make, we will get the 50 megahertz is a frequency, because FC is nothing but 1 by TC. So like that you can make the solution for that one. Got it? Right. Next, let me come to the next one here. Of course, this is a priority encoder. It is a direct question which already I said to you, all the students to you in our medicine notebook also you can check it. It's a direct question for the connections of this priority encoder. Outputs they asked the expressions. Those expressions based only they just asked that, you can check that one. Okay? Right. Thank you.
Yeah, student. Yeah, students. I'm going to take up the communication systems questions, and these questions which I'm discussing now, these are purely memory-based questions. Okay, so once the actual paper is out, official paper we get, so then we will take up all the questions with the detailed solutions. So now I am taking the questions which we received, which are purely memory based. Okay, and this year, so from the sources, I came to know that 8 questions came from communication systems, and by looking at those questions, I feel like most of the questions are easy questions only, except 1 or 2, and those 2 questions also moderate, I can say, not too tough. Okay, so this year I can say the communication systems will be kind of moderate, I can say. Okay, not too tough. Okay, some questions are very easy. Yeah, and if you see this question, and this is okay, very easy question, yes, no. So this is related to amplitude modulation. Okay, so this is an AM signal is given, and the carrier power is given, this is 50 watts, and the ratio of sideband to total power is 1/9. Then the value of B we have to find out. Yes, if you compare this with single tone AM signal, so this is the carrier term. Okay, this is, yeah, this is the carrier term, I can say. So AC is equals to, yeah, this is A only. Okay, from comparison, and these two are the sideband terms. Okay, so if you compare with single tone AM signal, this B will be equals to, I can say, AC mu by 2. Okay, so what is the single tone AM expression? AC cos 2 pi FCT plus AC mu by 2 cos 2 pi FC minus FMT plus AC mu by 2 cos 2 pi FC plus FMT. Okay, so from comparison, AC equals to A and B will be equals to AC mu by 2. So your carrier power is given 50 watts, so that is PC, I can say, and PC is equals to AC squared by 2. The resistance is not given, the default R you can take 1, so AC squared by 2 is 15. So from this you come to know AC will be equals to 10 volts. So AC, I mean to say A value only. So A is equals 10 volts. Then we have to find the B value. So for that you need to find mu first. Okay, so to find the mu here, so if you see, this is, yeah, so sideband power to the total power is given as 1/9. So this is PSB upon PT, it will be power efficiency eta only. So this is mu square by 2 plus mu square is equals to 1/9. So from this you will come to know mu equals to 1/2. So this B you have to find out. So this is AC mu by 2. Okay, so if you substitute AC is 10 and mu equals to 1/2 by 2, so this is 10 upon 4, this is 2.5. So 2.5 will be the answer for this. Okay, yeah, so this is pretty easy question, yes, no, yeah. And if you see this, the same model of question, yes, we done in the regular classroom. Okay, and even in the workbook also you can see the same model of question. So here X and Y are two independent random variables, and which are uniformly distributed in the interval 0 to 1. So if you see the density function of X, yes, so it is uniformly distributed in the interval 0 to 1. This is, the height of course will be 1, and Y is also uniformly distributed in the interval 0 to 1. So this is density function of Y. Yes, we have to find the probability of X greater than or equals to Y, we have to find out. I can write this as probability of X minus Y greater than or equal 0, I can write. This is X minus Y greater than or equal 0. Yeah. Now this is, I am writing this is probability of Z greater than or equal 0. This is, okay, where Z is equals to, I can continue here, where Z is equals to X minus Y. So X minus Y means I am writing this is X plus minus Y. So to get the probability of Z greater than or equal 0, we need the density function of Z. Yes, the area under probability density function will give you corresponding probability. Then what is the density function of Z here is Fz of Z is equals to, this is density function of X, this is convolution with density function of minus Y. this is. And what is the density function of x? This is, yes, it is 0 to 1, the height is 1, convolution width. And what is the density function of minus y? What are the range of values possible for y? 0 to 1. Then what are the range of values possible for minus y? That is minus 1 to 0. So this will be, yeah, yes, this will be minus 1 to 0. Okay, it is a density function of minus y. And if you do the convolution of these two, the convolution of two rectangular pulses, you will get a triangle like this. Yes, you will get this is minus 1, 1. The height also, yes, you will get 1. This is with respect to z. So it is a density function of z we got. So this is a density function of z. Then what is the probability of z greater than or equal 0? How to get the probability from density function? Area. So you have to find this area you have to find out. So what this area will be equals to 1 by 2. So 1 by 2, I can say this is 0.5 will be the answer for this. Okay, and even I said that in the classroom, I said that if the random variables are uniformly distributed in the same interval, then okay, every of those random variables will have equal chances to be largest and to be lowest. Okay, here probability of x greater than y means among x and y, what is the probability of x is the largest. Okay, so that will be equals to, of course, 1 by 2. Only two random variables are there. Then what is the probability of one of those random variables will be largest? So that will be equals to 1 by 2, I can say. So if there are three random variables which are uniformly distributed in the same interval, then what is the probability of one of the random variables to be largest is 1 by 3, like that. So here only two random variables is there, so that is 1 by 2 you will see. So 0.5 will be the answer. And if you see this question, this is a direct question, this is, yeah. So a source is emitting, okay, now alpha bit, okay, and this alpha bit consists of 16 possible symbols. Okay, so yes, you can understand that a source is emitting 16 possible symbols with equal 16 possible symbols. Then what is the maximum achievable entropy? Yes, so yes, if the source is emitting m possible symbols, capital M possible symbols, then what is the maximum entropy possible for that source will be log m base 2. Here, what is the maximum entropy possible for this source? This is, I can say, log 16 base 2. So log 16 base 2 will be the 4. Okay, so 4 will be the answer for this. Here entropy here is asking in bits. I said this, what I said is, even entropy is asking in bits per symbol or is asking in bits, so that is the same entropy, only you have to understand. So sometimes they're asking entropy in bits, they're specifying in bits, and sometimes they're specifying in bits per symbol, but that is going to be same only, it doesn't make any difference. Okay. And if you see this question also, the same question we done in the regular classroom. Okay, little difference is given, but the same thing, same question I can say. Okay, like if you see a Gaussian random variable w of t, okay, and this is what is the mean for it. The mean is given 0, and PST, the power spectral density of W of t, I'm denoting with SW of f, is given n0 by 2, and this is applied to the first order RC low pass filter. This is first order RC low pass filter. Yes, this output noise is n of t here. Now at a particular time t is equals tk, at some specific time instant tk, then what is the variance of this random variable n of tk we have to find out. Yes, so n of t you can see as a random process, every noise signal you can see as a random process. Okay, random process at a specific time instant will give you a random variable only. So I can see this n of tk as a random variable. So we have to find the variance of this random variable n of tk, we have to find out. Yes, here here input mean 0, then if you see output mean, if you see output mean is equals to, I can say, input mean into h of 0. Yes, if the input mean constant hai to, then this is how you can find output mean. This formula you can use to find output mean. Okay, so input mean 0 hai na, so input mean 0 means output mean also directly I can say will be 0 only. Okay, and we have to find the variance of n of t. Okay, So variance is equals to, this is mean square value minus square of mean, I can say, minus square of mean. So the mean here is 0. Okay, then I can say the variance will be same as the mean square value, I can say. Okay, will be same as mean square value, but we have to find at a specific time instant tk, we have to find out at a specific time instant tk, then what is the variance of nt will be equals to, this is expectation of n square tk. So you can write this as expectation of ntk times to ntk. Okay, so that will be will give you autocorrelation function only, the autocorrelation function of nt. Okay, and what is the time difference is 0. So this is, I can write n of tk into n of tk, the time difference will be 0, so that is Rn of 0, I can say. Yes, expectation of product will give you correlation only. Okay, so it is the same random process n of t and n of t, so that will be autocorrelation only. So it is autocorrelation of nt with the time difference 0. Okay, Rn of 0. So it is simply ACF at the origin will give you power only. So simply here the output noise power you have to find out, that's it. Okay, so irrespective of the time instant, what may be this time instant. Okay, so this what you see here, so that will give you simply the power only. Okay, so you can understand this question as if a white noise signal, okay, having 0 mean PST N0 by 2 is passed through RC low pass filter, what will be the output noise power we have to find out simply. So what is output noise power? That is N0 by 4 RC. No? The same question we done in the regular classroom, N0 by 4 RC. Even if you see this, okay, to find the output ACF, first I will find out the output PST, because input PST is given, output PST you can find out. So I am continuing here, output PST is equals to, this is input PST into mod HF square, this is. So this will be input PST to N0 by 2 and mod HF square. Okay, what is the transfer function of this low pass filter? If you see, this is, so HF is equals to 1 by 1 plus j omega RC, this is. In place of omega you can write 2 pi f, of course you can write. So this is, so mod HF square is 1 plus, this is omega RC square. So in place of omega, of course you can write 2 pi f. Then what is the autocorrelation function of output? That is R n tau is equals to the inverse Fourier transformation of PST will give you autocorrelation function. So what is the inverse Fourier transformation of this? You will get N0 upon 4 RC e power minus mod tau by RC. Or simply here the total area under this PST also will give you this power, okay. Otherwise, okay, the inverse Fourier transformation of PST will give you ACF, and I have to find ACF at the origin, we have to find out. Yes, no, this is now Rn0. So in place of tau, if you substitute 0, this is N0 by 4 RC. Okay, that will be the answer. Okay, so it is also the same question we done, okay, in the regular classroom. So most of the questions are the same like what we done in the regular classroom. Yes. Now, so this is related to random process. So this is also easy question only. I see this is an easy question only. Here a and theta random process nahi, it is random variables actually. Random variables. Here a random process is given like this, and where a and theta are random variables, and a is uniformly distributed in minus 2 comma 2, and theta is uniformly distributed in 0 comma 2 pi. And of course he might mention in the question like a and theta are independent, of course he will mention that, and the ACF also is given to us. Okay, even if you find out from this given data, if you find out the autocorrelation function of xt, you will get this was only, but he directly given in the question itself, it's a good thing. And this xt is given to 8-bit mid-rise quantizer, fine. Then what is the SNR you have to find out, signal to quantization noise power ratio you have to find out. So what is signal power? Okay, the power, this is the power of xt, because this xt is getting quantized. Okay, so signal power means the power of xt only. Okay, and ACF of xt is given, so ACF at the origin will give you power only, so this is Rx0, so this is 2 by 3. And if you see the quantization noise power, so this is delta square by 12. Okay, Yes, simply mid-rise quantizer means that is the default of uniform quantizer only you can understand, and for uniform quantization the quantization noise power is delta square by 12, and this delta here is equals to, this is peak to peak upon L I can write. And what is the peak to peak of xt? Okay, so here A is uniformly distributed in -2, -2, means what are the range of values possible for A, that is in between -2 and 2 you can understand. Means at every of the time instant, A can be any value between -2 and 2. Okay, so if you plot x of t, so you can expect like this, x of t is some random signal of course. Okay, so it takes the values between -2 and 2 you can expect, some random signal x of t is. Okay, the range of values possible for A is in between -2 and 2 means, so the range of values possible for xt also I can say in between -2 and 2, I can say -2 and 2. Okay, yes. Now what is the peak to peak of xt? I can say 4. Peak to peak of xt, the range of values possible for A is in between -a and A means -2 and 2 means the range of values possible for A in between -2 and 2 means the range of values possible for xt also in between -2 and 2 we can expect. Okay, so the peak to peak of xt is 4, so L is equals to power n, so n equals to 8, so this is, yeah, this will be. Then if you substitute here nq delta square, this is delta, so delta square upon 12, and if you find out, if you substitute, so S by nq you will get 32,768 you will get. The substitute you will get this, and in dB, if at all, if he is expecting in dB, I don't know whether he is asking direct SQNR he is asking or in dB he is asking. Okay, if he is asking what is the direct SQNR, that is 32,768 will be the answer, and if he is expecting in dB, I can say, so S by nq in dB, so 10 log of this, and if you see 10 log of 32,768, so you will get 45.15 dB. So in dB that will be the answer. Okay, so the questions are easy now. Yeah. And if you see this question, this is also related to inter-symbol interference. Okay. Yes. So here I'm not sure like about the terminology of the question. I'm not so sure about the terminology of this. Means, so what exactly the terminology is given, we have to see that once the official gate paper is released. Okay. Here, yes, he given that here Bn is the symbols you can understand. Okay, binary sequence you can understand, and this is transmitted through some filter, and the output of the filter is this. Okay, so it's like you can see the discrete convolution between Bn and x of t. Discrete convolution between Bn and x of t means it is something like I'm passing this through this binary sequence. I'm passing through a system. Okay, I'm passing through a system and having the impulse response like x of t, like this is, it is like this, and the output is, this is yt you can understand here. Okay, and yes, fine. So I'm passing this binary sequence through some filter, and where the filter having the response of the filter is something like x of t is given, and the output is yt here. Okay, fine. If you understand, like if you expand it, for example, if you expand it, this is, so at n equals 0, this is, if you see b naught into, this is xt. Okay, okay, so this b naught means that can be 0 or that can be 1, you can understand, and that is multiplied with x of t. This x of t, it can be I mean to say, you can see this x of t as a rise to cosine pulse or sinc pulse, you can understand. Okay, this is because for 0 inter-symbol interference. Okay, so we have to represent binary sequence with rise to cosine pulses or sinc pulses, we have to represent. Yes, no? Yes. So here b naught is equals to, for example, if you use on-off coding, for example, in on-off coding, if it is in on-off coding, binary 1 represented with the presence of pulse. Okay, and binary 0 is represented with absence of pulse, 0 volts. Okay, if you use, for example, on-off coding, and so if the first bit is, for example, 1, so 1 into xt means xt, so 1 represented with presence of pulse, And what that pulse means, that depends on which shape of pulses you are using. If you are using raised cosine pulses, then one represented with presence of raised cosine pulse. Okay, and next if you expand it, it is b1 into x of t minus t, you can understand. Okay, so the second bit, okay, so each bit duration you can understand t, each bit duration is capital T, you can understand. So the second bit is multiplied with x of t minus t. Okay, so that that raised cosine pulse is delayed with delayed by capital T, and that is multiplied with b1. Okay, that b1 can be 1 or 0, you can understand like this. So it's how you, what you can understand here is, okay, so here the representing this, what you see here, it is you can understand this as representing the binary sequence with electrical pulses, okay, and what that electrical pulse is x of t, you can understand. Okay, so if you take for example on off coding, if it is 1, for example, if it is 1, b1 is 1, for example, b naught is equals 1, and b1 second bit is 0, for example, you can understand like that. Okay, if you use on off coding, so binary 1 represented with presence of raised cosine pulse, and binary 0 is represented with the absence of raised cosine pulse, something like that. Okay, fine. If you use for example polar coding means binary 1 represented with okay, positive pulse, and binary 0 represented by negative pulse, something like that. So it is simply, you can understand as representing the binary sequence with electrical pulses. The electrical pulses can be raised cosine pulses or sinc pulses, can be any of like. Okay, now here this for 0 ISI, what should be the condition that should be satisfied by xt? Okay, means with which pulse you are representing binary sequence. So what that condition to be satisfied by that pulse for 0 ISI, we have to find out. Yes, you remember this, like in the regular classroom I said that for 0 ISI, with which pulse you are representing the binary sequence. Okay, that pulse I am denoting with x of t here, with which pulse you are representing binary sequence. For that pulse, 0 crossings, this is 0 crossing should occur at, okay, this is plus minus t, each bit duration here you can understand capital T. Okay, so if the bit duration TB hai to, if at all bit duration is TB, so 0 crossing should occur at plus minus TB, plus minus 2 TB, plus minus 3 TB. Here bit duration is capital T, so 0 crossing should occur at plus minus T, plus minus 2T, and it's go on. Okay, so this is the condition to be satisfied by xt. Then what should be the condition satisfied by xf, we have to find out. Okay, already I derived this condition in the regular classroom. Yeah, I can give you that condition once again. So if you see some raised cosine pulse I am taking, some sinc pulse or raised cosine pulse, xt I am taking, and for this 0 crossing should occur at t, 2t, and this is minus t, minus 2t, and it's go on. Yes. Okay, if this is the condition satisfied by xt, what the condition satisfied by xf, we have to see that. Okay, to get that condition, if you multiply this with the impulse sequence like this, I am multiplying with impulse sequence like 0, t, minus t, the height I am taking 1. So this is summation, I can say n equals to minus infinite to infinite del t minus nt. Okay, just if you multiply with this such, if you multiply such pulse with this impulse sequence like xt and multiplied with n equals to minus infinite to infinite del t minus nt, if you multiply these two, okay, so all other impulses will get vanished, because at t, 2t, 3t it is 0 here, so 0 multiplied with something, that will be 0. So we left with only here this del of t, okay, this xt multiplied with del t. Okay, so this xt multiplied with del t, you can write as x0 times 2 del t, you can write. Okay, and if you apply now Fourier transformation on both sides, okay, so what is the Fourier transformation on both sides? This is 1 upon t, this is summation, I am writing m equals to minus infinite to infinite x f minus m upon t, okay, is equals to, so what is the Fourier transformation of this? This is x0 only. Okay, and this is, I can write m equals to minus infinite to infinite x f minus m upon t x0 into capital T, I can write. Okay, so by assuming this x of t at t is equal 0 as 1, suppose if you take this as, yeah, but suppose if you take to match with the answers given, So if you take x of t is equal 0 as 1, so then this is the condition to be satisfied by the spectrum xf. And because it is summation m equals minus infinite infinite, you can write this as minus or you can write this plus also. It doesn't make any difference. It won't make any difference. Okay, you can write that as minus, you can write this as plus also. Then which option is going to be correct here? This is, yeah, this looks to be option C will be correct here. Yes, no? Yes. Yes. Yeah. Yeah. Option C looks to be correct. Yes. Yeah. So this is the same question we done in the regular classroom. Okay, with a little terminology got changed, but the same question we done. Yes. And one more question, if you see, this question is also given. Yeah. So this is one tricky question. Okay. Here a source is transmitting 3 symbols here. So the source R is transmitting 3 symbols -404 with equal probabilities over a Gaussian channel here, where that specifications of the Gaussian noise is given with 0 mean and variance 4. Then the optimum probability of error for the given system we have to find out. So here you can understand like this. This R, okay. So the source R is transmitted here. This is transmitted through AWGN channel, means it is interference with noise, you can understand. Okay, and the input of the receiver I am denoting with Z. Z is equals to R plus NT, and of course it is sampled. Okay, with the bit interval. With bit interval I am taking them some TB. Okay, and after sampling, what that sampled value you will get, that is given to threshold comparator. Okay, and this is the threshold voltage. So based on that Z value, the decision will be taken in favor of -4 or 0 or 4. The decision will be taken, okay, based on the received value Z. Okay, then here what is the optimum probability of error? You have to find out what is the minimum possible probability of error. We have to find out. Okay, yes. So here what the specifications of this noise is given. So it is having 0 mean here. This is okay. So expectation of N0 and variance of noise is given as 4. Okay, so it will be, so 0 mean and variance is 4 for this. Now what is the probability of error? We have to find out. Here 3 possible symbols transmitted here, -404. Okay, so if you take a binary system, for example, where 0 and 1 is transmitted, then what is the probability of error? So if you take, for example, binary system, what is the probability of error? 0 emit होने के लिए क्या chances है? When 0 emitted, what will be the chances of error? It is one possibility for error to occur. Or another possibility for error to occur, 1 emit होने के लिए क्या chances है? And when 1 emitted, what will be the chances of error? है ना? Now it is for a binary system. Okay, and what about for this given system के लिए? Here 3 possible symbols transmitted. So what is the probability of -4 transmitted, and what is the probability of error when -4 transmitted, and what is the probability for 0 to be transmitted, and when 0 emitted, 0 transmitted, what will be chances of error, and 4 emit होने के लिए क्या chances है? When 4 emitted, what will be the chances of error? We have to find out. And each of these symbols emitted with equal probability. So P -4, P0, P4, that is 1/3 only. So equal probability. So 1/3 times of this is PE -4, PE0, PE4. Okay. Now if you see when -4 transmitted, transmission of -4, what will be the Z value? Okay, Z value is what? -4 plus this is the noise. -4 plus noise. So if you sample the random process, NT you can see is random process. Sampling of random process will give you random variable only. The random variable I am denoting with N. Okay, so this is. Now what is the density function of Z here? This is. So if you say what is the X, I will make it like this. Yes. So what is the density function of Z? Is Gaussian density function only, because N having Gaussian density function, Z also will have Gaussian density function only. So what is the expectation of Z? That is -4, because expectation of N is 0, and variance of Z. So variance of Z will be, I can say, same as variance of N, that is 4. Okay. So here I can see this as, so when -4 transmitted, this is, and Z is having Gaussian density function, or I can say normal density function, with the mean is what? 4, and variance is 4. n of a comma sigma squared. In compact form you can write like this, Gaussian density function. And this is when -4 transmitted, yes, no? And if you see when 0 transmitted, in transmission of 0, okay, then z will be equal to 0 plus n. Then I can say this z I can write as, it is having Gaussian density function with 0 mean and variance 4 will be like this. And in transmission of 4, this is, then z will be equals to, this is 4 plus n. So this z I can write as, it is having Gaussian density function with mean 4 and variance will be same as variance of n, that is 4, this is. And if you plot to get the probability of error, you need the density function of z when -4 transmitted, 0 transmitted, 4 transmitted. So this is, so if you plot these 3 density functions at one point of place, so it will be like this, okay, this is, so this is this. So I can say this is density function of z, this is when -4 transmitted, okay, it is a density function of z when 0 transmitted, and this is density function of z when 4 transmitted. It is centered at the Gaussian density function centered at its mean, okay. So what is a mean when -4 transmitted? This is -4 and this is 0, and when the symbol 4 transmitted, what is the mean is 4 only, so it is with respect to z, okay. So you have to find probability of error, you have to find out. Optimum probability of error means with optimum threshold only you have to find the corresponding probability of error. So to find the optimum threshold you can use map theorem, okay. So according to map theorem, okay, so V threshold will be equals to, I can say this is A1 plus A2 by 2, the regular classroom I given this. If the mean is A1 for this, if the mean of one symbol is A1, the mean of another symbol is A2, then the V threshold will be A1 plus A2 by 2, where you are dealing with Gaussian density functions, okay, Gaussian density functions. So here, when -4 is transmitted, corresponding to -4 transmitted, the V threshold I can say this as -2, I can say this is the average of this -4 and 0, that is V threshold is -2, and corresponding to 0 transmitted, okay, okay, yes, the V threshold I can say this is the average of 0 and 4, this is 2, I can say, okay. So if you see what is the probability of error, yes, if you see, yes, so the probability of error when -4 transmitted, okay, so it is nothing but when it is corresponding to transmission of -4. You can see this as, so when -4 transmitted, what will be the chances of z if when -4 transmitted, okay, for error to occur, if at all that received, this is z value, if you say z and threshold comparator, and this is V threshold. Now what you can understand is when -4 transmitted from the source, if the received z value, if it all greater than -2, then there will be the chances of error you can expect. If z is greater than -2, so that can be decoded as 0 or that can be decoded as 4, I can say, okay. If at all this received z value greater than -2, that is decoded as 0, I can understand, okay. If the received z value is greater than 2, that will be decoded as 4. So altogether, if the z value is greater than -2, so that will be decoded as error, that can be decoded as 0 or 4, but that is definitely going to be error only. So what will be the chances of error when -4 transmitted is, when -4 transmitted, what will be the probability of z greater than -2? What is the probability of z greater than -2? So this is, yes, it is integration -2 to infinite, and this is the area under, okay, this is dz. So it is, yes, it is when density function of z when -4 transmitted, no, this is -4 transmitted, density function of z when -4 transmitted, this is, okay. So how to get probability from density function? Area. Yes, it is when -4 transmitted, no? So what is the density function of z when -4 transmitted, and so what is the probability of z greater than -2? I have to find out. Yes, so it will be equals to, yes, so it is just looking like finding the area under Gaussian density function only. To find the area under Gaussian density function, you can take the help of Q function, okay. Yes, here I can see this, I can write this as, so if you remember, So if you see, for example, if you have some random variable x of x equals n of a comma sigma square, then what is the distribution function of x? The distribution function of x is, I can write this as 1 minus q of x minus a by sigma. It is a formula I given in the regular classroom. To find the area under the Gaussian density function, or I can say the distribution function of the Gaussian random variable, you can write in terms of q function, 1 minus q of x minus a by sigma. Fx of x means it is probability of x less than or equal to x only. This is, yes, no? Yes. So here I can write p probability of error when minus 4 transmitted. I will write this in terms of distribution function. So it is 1 minus, this is, yes, probability of z less than minus 2 I can write. So this will be, so 1 minus, this is fz of minus 2, okay, and it will be equals to, so what is the distribution function you can write? 1 minus q of x minus, x is minus 2. What is a mean? A means mean. So when minus 4 transmitted, what is the mean is minus 4 only. So this is minus of minus 4 is plus 4 only. Sigma is 2 I can say. Sigma square is 4, so sigma is 2. So from this you will come to know q of 1 you will get. This will be, okay. And similarly, if you see, I will do here itself. What is the probability of error when 0 transmitted? It is, yes, when 0 transmitted, if the z value less than minus 2, less than v threshold, if the z value less than v threshold, that is decoded as minus 4. If the z value greater than 2, that is decoded as 4, okay. So when 0 transmitted, I can say if z value less than minus 2 or z value greater than 2, definitely there will be the chances of error. So I can say, so it is simply, it is nothing but when 0 transmitted, what is the probability of z less than minus 2? R means plus, and this is z greater than 2 I can say. Yes, when minus 4 transmitted, if z is greater than minus 2, then that leads to error I can say. But when 0 transmitted, 2 possibilities you can say. When 0 transmitted, even z less than minus 2 or z greater than 2, definitely that leads to error, okay. So it will be, it is when transmission of 0 I can say. It is transmission of 0. Yes, to find the area under the Gaussian density function, you can take the help of q function, okay. So I can write this in terms of q function. So yes, I can write this as 1 minus fz of minus 2 I can write, this is, plus this is, yeah, it is directly you can write, no? Yes, probability of z less than minus 2 means it is fz of minus 2 only, this is, plus, so it is 1 minus fz of 2 you can write, okay. So distribution function is 1 minus q of x minus a by sigma. So x is what here? Minus 2. A, the mean is what? When 0 transmitted, what is the mean? 0 only, okay. Sigma is 2 of course, yes, plus, yes, 1 minus fz of 2. You can see this is, if you see this distribution function, this is the formula distribution function. So 1 minus fx of x is, that is q of x minus a by sigma only, 1 minus fx of x is, okay, q of x minus a by sigma. So directly I can write this as, okay, q of x, x means what? 2, a is 0 and sigma is equals to 2, this is, and it will be 1 minus q of minus 1 plus this is q of 1. So 1 minus q of minus 1 is, that is q of 1 only, yes. Yes, if you see, what is this? I'm finding how to get the probability from density function area. So what is the probability of, this is, okay, z less than minus 2. Probability of z less than minus 2 means this area you have to find out, okay. And what is the probability of z greater than 2 means this area you have to find out. So definitely this area and this area you will get same only. Z greater than 2 ke liye, z less than minus 2 ke liye, this area is same only. So this probability you get same only. Yes, you can see this is q1. So this is also definitely q1 only, this is going to be. So 1 minus q of minus 1 is q1 you can write. Yes, this is q1 plus or q minus 1 is equals to 1, or I can say simply qx plus q of minus x, it is equals to 1. It is one property of the q function. Yes, if you see, so q function means it is, you can say this as, if you have the Gaussian density function with mean 0, variance 1, the area under this Gaussian density function for x greater than this area under this Gaussian density function, so this will be equal to qx. This is the q function you can say. If you see the 0 mean and unit variance, the area under this Gaussian density function greater than x, okay, this area will be equals qx, you can write. And if you see qx plus q minus x is equals 1, I am saying qx means what? Area from x to infinite, this area, and q minus x means what? This is q minus x means this, you can see this is this area, you can see this total area, okay. So this qx plus q minus x will be of course equals to 1 only, this is because this is this qx now, this what you see, you can say this is qx now, okay, and this area is going to be same only, this area and this area is going to be same only. So if you find this area plus this area, so this area qx means this plus q minus x means this, okay. So this q minus x go yes, qx you see qx means you can see this area also, so this area also you can see as qx, yes, no, this is, so this area also, this area what you see, this is also you can see as qx. Now you can see, so qx means this area, q minus x is this area, okay. Now qx plus q minus x of course will be equals to 1, yes, once again I am writing here, if you see this is, yes, so this is q minus x means this area, yes, this is, let me write here, so this is q minus x, this is, okay, and this area will be qx, I can say, this area also you can see as, this area you can see is qx. So qx plus q minus x is, that is the total area under this Gaussian density function whose mean is 0 and variance 1. This total area under Gaussian density function is 1 only, okay. So qx plus q minus x is 1, okay, yes. So this this I can write q1 only, okay, yes, and this is q1, so this is 2 times to q1, okay. Then you have to find what is the probability of error when 4 transmitted, yes, I'm sorry, this is, yeah, oh shit, yeah, so it is when 4 transmitted. So what is the probability of error when 4 transmitted? Yes, when 4 transmitted, what will be the chances of error is nothing but when 4 transmitted, what are the chances of the z less than 2? Okay, if the z value less than 2, then that is decoded as 0 or minus 4, mean that leads to error, means, so when 4 transmitted, what will be the chances of z less than 2, I have to find out. So this is, what is the chances of z less than 2, I can say, this is, okay. So this is, I can write this is fz of 2 only, so this is 1 minus q of, so x minus means 2 minus a will be 4, the mean is 4 by sigma will be equals to 2. So this is 1 minus q of minus 1, I can write this is q of 1 only. Then altogether the probability of error will be equals to, so what is the probability of error? That is 1 by 3 times, to add all this probability of errors, this is q1 plus 2q1 plus q1, so this is, so 4 by 3 q1, so 4 upon 3 q1 will be the answer for this, okay. And I came to know that one question came from CRC also, cyclic redundancy check, but exact data is not available with me, but that is a simple question only, like what we done in the regular classroom. Message sequence is given and generated polynomial is given, then you have to find out the transmitted code word in CRC. That is same like the same model of question we done in the regular classroom only, but exact data is not available, so I am not doing that question, okay. But so these are the questions given from communication systems. I discussed 7 questions already and 1 question that is related to CRC, but the exact data is not available, so I am not doing that question. So now I think you understood, like these questions from communication systems given mostly easy questions only, most of the questions we done in the regular classroom, so 1 or 2 tricky questions given, that's it, okay. So I hope you done good, okay, in the examination, okay. So thank you guys, okay, all the very best.
Dear students, GATE EC branch 2024 reasoning aptitude memory based questions. See, we given in the classroom number of prime factors and different prime factors and also total factors. So it is one of the question. Highest prime factor of 3 power 199 minus 3 power 196. So we can take the common for both of them, 196 common, 3 cube minus 1, 27 minus 1, 26. 26 we are writing of 2 into 30. So when you are comparing 3 is a prime number, 2 is a prime number, 13 is also prime number. What is the highest prime factor? 13. See, these questions, highest prime factor and number of prime factors, different prime factors, you have done many things. So finally, highest prime factor according to given multiple choice, C is the answer. So prime factors, we have done even prime factors, odd prime factors. It's one of the question. Second one. See, I given under miscellaneous part, logarithms. Logarithms, quadratic equations, indices, I told you is very important and just is only basic concepts. It is depend upon a log of log m base n. Comes to denominator log n base m. Once goes to numerator, base will be changing. So 1 dividing by log x base 2, 1 dividing by log x base 3, 1 dividing by log x base 4 equal to 1. They want to find out value of x. X must be greater than 1. So we are writing base changing, come to base will be x, log 2 base x according to this formula. According to this formula. And second one, log 3 base x, third one, log 4 base x equal to 1. It is in the form of log a plus log b plus log c, log of abc. Now, cancellation of logarithm, n is equal to a power x, log n base is equal to x. What is the value of x is equal to 24. X is equal to 24. According to given multiple choice, 24. So we have done logarithms. Similar problem. Sometimes it is almost equal to what you have done. X value completed there 343 dividing by 125. Here x value 24. It is the second problem. This all will be memory based questions. Third question. So it is given 2021 similar question. We have done in the miscellaneous topics. We folded the paper, longer side and smaller side. There we got the answer, two different rectangular shape. See, it is rectangular shape 24 centimeters, 16 centimeters. First condition, paper fold parallel to longer side. How many times? 2 times. Second condition, paper fold parallel to smaller side 2 times. So they want to find out first condition, second condition. What is the perimeter of first condition to second condition? So once we are go through our workbook, we have done same similar problem. Only answers are different. So now come to the here. Parallel to longer side 2 times. First condition 24, 16. What is the longer side? 24 as it is. 16 becomes 8. Now second time 24 as it is 4 becomes will be 8 dividing by 2. We are making half of 16 8. 8 of 4. It is the parallel to longer side. Longer side as it is. Now perimeter 2 into L plus B. 24 plus 4 28. 2 into 28. So this is a longer side. Coming to smaller side. Now second condition 24 16. Here what is smaller side? When you comparing of these two, 16 is smaller side, 24 by 2, 12. Now when you are comparing these two, 12 is smaller side. 12 as it is, 16 becomes 8. So most important, 12 as it is, 16 becomes. Now it's a perimeter 2 into L plus B, 12 plus 8, 20, 2 into 20. So first condition 2 into 28, second condition 2 into 20, ratio of first condition to second condition. 2 into 28 by 2 into 20. 2 will be cancelled. 7 into 4 times 7 into 5 times. Therefore, ratio for this 7 dividing by 5, that is called 7:5. See, once again, First condition, parallel to longer side twice. So longer side as it is 16 becomes will be 8, half of that. Now second one, 24 will be as it is 8 dividing by 4. So first condition 2 times complete this perimeter 2 into L plus B. Now parallel to smaller side 16 will be as it is 24 by 12. When you are comparing of these two, 12 as it is 16 by 8. So this perimeter 2 into L plus B. So perimeter of the first condition, perimeter of second condition, that is 7 dividing by 5, 7:5. It is all same like workbook problem. Workbook with different answer, this answer is different. It is a third question. Fourth one, we have done ratio proportion. There will be different answers. So 5 years ago, son and father age was 1:4. After 5 years, the ratio was 2:5. Find the father age at the birth of the son. We have done in the classroom, wife and husband. And there will be different answers. Now see that. So we are writing of son is equal to S, father of 5 years ago, S minus 5, father minus 5 equal to 1/4, first condition. Wherever ago is equal to minus. And after 5 years, son plus 5 years, father plus 5 years, second condition. Taking first and second condition, taking first and second, taking these two conditions, solving both, we are getting son is 15 years, father 45 years. But they are asking age of the father at the birth of son. So 15 years ago, birth of the son, 45 minus 30, 45 minus 15, 30 years. So 5 years ago, 5 years after, son age minus 5 years, father age minus 5 years, first condition. After 5 years, 2 dividing by 5, solving both the equations, son is equal to 15 years, father 45 years. They are asking father age at the birth of the son, 45 minus 15, 30 years. Ratio, proportion, we have done workbook, same similar problem. There may be different answers, but method is same thing. We are to the point. I think you all of you understood. That is, see, these are memory based questions. See, I am repeating once again. Third question. Just now we completed parallel to longer side, parallel to smaller side. The ratio will be 7:5. Coming to second question. So it is in the form of base changes. 1 dividing by log n base m comes to denominator, base will be changes. So it is the log of a plus b log abc. Cancellation of logarithm x is equal to 24. This x value 24. Coming to very first question. So it is the highest prime factor and also sometimes maximum prime factor. So for both of them common 196, 27 minus 1 26. We are writing 2 into 13. Highest prime factor is 13. So these are memory based questions. There is 3 more questions. Mirror image. One problem they given 4 circulars. And remain questions also simple, but data was not subset. Thank you for all.
Hello dear students. So now I am going to give the solutions of engineering mathematics questions asked in the electronics. Okay. Now I think we have seen some certain questions here which are memory based here, right? So let's give the solutions of this here. You can see this y of t is the complementary function. We all know that the complementary function is given by is obtained from the auxiliary equation, the roots of the auxiliary equation here. So if we go and then we have to find out the differential equation here. If you want to have the differential equation from the solution, then we have to go in reverse, right? We have to go in reverse property. So based on the reverse process, you can see that it is -2 is the root here, and this root is, see, the solutions are t into e power minus 2t and e power minus 2t is here. So that means it is very clear the root -2 is repeating twice. It is the root twice here. If it is the root twice, so then what we can do? If the root is twice means, so you can write the auxiliary equation f of m is equal to m plus 2 whole square here, right? So therefore the differential equation will be of f of d into y is equal to 0 for a homogeneous, you can assume now, as of now, or other homogeneous equation we can assume now. So therefore it will be d plus 2 whole square into y is equal to 0, which will be y double dash plus 4y dash plus 4y is equal to 0 here, right or not? So now if you look at this, so none of the option, only option B is satisfying here, right? Only B is the answer for this. It's a very easy question, and even my dear students, this is a direct workbook question beta. Direct workbook question है, workbook question same है, वही question आपको examination में आया. It's very easy part. Now this question you see that this is the syllabus which is there for only electronic students, right? So the concept is that the following vectors do not form a basis for any vector space, then find the A. There is something data is missing here, but we can say it is something of R cube, three-dimensional real space of vectors. So in this you can see these three vectors do not form a basis, but you know these three vectors is forming a basis means, so these three vectors must be linearly independent, so then only it forms a basis here, right or not? Then only it can form a basis here. Okay, so therefore if it is not a basis means they are not linearly independent, so therefore I can say that there must be a linear dependency. Linear dependency means the determinant of these vectors must be equal to 0, that is 2 minus 3a and 3 minus 1 and 3 here, 1 minus 5, 7 here. So then you are going to get the value of a here. So when a is pi, it is very clear these set of vectors are linearly dependent, hence they are not linearly independent, hence these vectors cannot form a basis here. So therefore the answer is 5 for this. Okay, the next one beta, ये तो बहुत easy है बेटा, but you should know the process of finding the eigenvalues here, eigenvalues, and after knowing the eigenvalues,
White matter, dark color, blue, black.
so here we can find out these eigenvalues. First of all, we know that the eigenvalues are given by what? Mod of a minus lambda I is equal to 0 here, that is 1 minus lambda k, and 2 1 minus lambda is equal to 0 here. If you solve this equation, that is lambda square minus 2 lambda here, and then it is 2 minus 2k here, right or not? So this is here 2 minus 2k, so here plus 2 minus 2k is equal to 0. So then if you solve this quadratic equation here, when you solve this quadratic equation, you are going to get it is a 1 plus or minus root 2k here, you get it. So 1 plus or minus root k are the eigenvalues you will be getting here. So therefore 1, you can take 1 plus root. Now substitute, or do one thing, you can do like this also. Once you get the eigenvalues, if you want to have the eigenvectors, the simple process is that verify, you have to verify the ax is equal to lambda x with the given options, here, right or not? So whichever satisfies, that is the answer. So right now I don't have any options here, right? but you know, you can just, once you get the eigenvalues, just place this eigenvalue lambda here and take the x from the options and see whichever x satisfies this x is equal to lambda x, that will be the answer for the question here. Okay, so I hope this one everyone has done this question, right? Now the point is this one, this is completely vector based question बेटा, आपको बार बार क्लास में यही कहता हूँ. So EMT के अंदर से आपको वेक्टर का एप्लीकेशंस होते हैं. So therefore that's a very very important topic. क्लास में हम लोग बहुत क्वेश्चन सॉल्व करते हैं वेक्टर्स के अंदर, आपको पता है. तो यहाँ पर देख लीजिए, ये इक्वेशन देख लीजिए बेटा, ये जो डो पी बाई डो टी दिया ना, तो डो पी बाई, ये डो पी बाई डो टी है. So this can be written as minus divergence of rho u, here it is given, right? So this is the way you can write that equation. Now according to that, which of the following is the right one? See, simple my dear, अगर आप थोड़ा ध्यान से देखते हैं, ये सारे ये वॉल्यूम इंटीग्रल है, राइट? ये वॉल्यूम इंटीग्रल है. सो अगर मैं दोनों तरफ वॉल्यूम इंटीग्रल ले लेता हूं, अगर दोनों तरफ वॉल्यूम इंटीग्रल ले लेता हूं, तो ये बनेगा, ये देखो, फर्स्ट वन और नॉट, फर्स्ट वन इज द ट्रू वन, सो फर्स्ट वन इज द करेक्ट. अब जब आप ये, let us do one thing. So suppose if this is of some f bar, so this is can be written as dv, can be written as what here? See, this can be by using Gauss divergence theorem. So we can write this as a surface integral, right? And that is f bar dot n cap ds. So this one. So rho u bar dot n cap ds here. So therefore, and this is minus again. It is minus again. So option C is also true here. So these are the answers. A and C are the answers for this. So these are the things, something which are not matching here, because here minus is missing over there. So therefore only these two are the correct answers here. So I hope everyone has done this question, because ये बहुत basic question है बेटा, ठीक है? डायरेक्ट गॉस डाइवर्जेंस थ्योरम एप्लीकेशन का है, मगर उसका लैंग्वेज समझ में आना चाहिए. वो कौन सी ऑप्शंस के हिसाब से कभी कभी काम करना पड़ता है, तो ऑप्शंस को देख करके उसकी जैसे आंसर लेने का कोशिश करना है. चलो, दिस इज एफ बार बेटा. ये हमारा, आपको पता है, मैं बोल रहा हूँ, जो मेरा स्टूडेंट्स है वो क्लास में अभी वॉच कर रहे हैं ना, तो दे नो इट वेरी वेरी क्लियर. ये हमारा एमएसक्यू वर्कबुक से क्वेश्चन है कि नहीं, एक बार देख लीजिए. सीधा सीधा ऑप्शन के हिसाब से मैं बोल रहा हूँ, ऑप्शंस भी साथ साथ सेम एमएसक्यू वर्कबुक क्वेश्चन के सीधी सीधी आया गया, एमएसक्यू वर्कबुक क्वेश्चन, राइट? आई थिंक आई हैव गिवन द लिंक फॉर दैट फ्रॉम माय क्लास, इन माय क्लास, राइट? ओके बेटा, दिस इंटीग्रल इज इंडिपेंडेंट ऑफ पाथ सी, ही सेड. अगर ये इंटीग्रल पाथ है, so it is independent of path hai, so then f bar can be written as a del phi bar, right or not? F bar can be written as a del phi bar. So here, so this f bar can be understood as a del phi, you can say, and therefore this one, there exists a scalar function phi, f bar is equal to del phi. This is the first one is correct, and this one, divergence of this one is equal to 0. No, divergence of del phi bar is not equal to, need not to be 0 here. So therefore it is wrong. So next one is this one, dou f3 by dou y, dou f2 by dou x, and in this one. So when you do the curl f bar beta, आपको पता है, जब f bar can be written as a del phi bar, you know that this can be written as a curl f bar is equal to 0, right or not? ये तो आपको कर्ल की डेफिनेशन में पता है, राइट और नॉट? तो ये क्लासरूम में हम बहुत अच्छी तरह डिस्कस करते हैं. जब आप इसका डेल को 0 करके आप देखते हैं ना, तो यू कैन सी दैट इट इज डो बाई डो एक्स, डो बाई डो वाई, एंड यहाँ पर डो बाई डो जेड आएगा, और ये f1 होगा, ये f2 होगा, अगर f3 होगा, f2 होगा, ये f3 होगा. आपस में अगर आप ये इसका क्रॉस प्रोडक्ट कर लेते हैं ना, तो ये आएगा डो f3 बाई डो वाई माइनस डो f2 बाई डो एक्स. उस तरफ तो 0 वेक्टर होना चाहिए, उस तरफ तो 0 वेक्टर होना चाहिए. सो देयरफॉर, सो डो f3 बाई डो f5 इज इक्वल डो f2 बाई डो x. मतलब अगर ये दोनों इक्वल होता है ना, तभी तो इसका i component 0 होगा और j component 0 होगा, दिस वन. सो because of this j component will be 0, this because of this k component will be 0. So that means, so when del cross f bar is getting 0, so these are the derivatives are getting equal here. So therefore this is also correct here. ये आपको पता है बेटा, जो हमारा क्लास में समझते हैं शॉर्टकट वाला, सिंपल है कि जब भी ये पाथ इंटीग्रल है, सॉरी, इंटीग्रल इज इंडिपेंडेंट ऑफ पाथ है,
इंटीग्रल इंडिपेंडेंट ऑफ पाथ है, तो सीधा सीधा जब क्लोज्ड इंटीग्रल क्या होगा, 0 होगा, ये भी पता है, राइट और नॉट। ये हमारा शॉर्टकट है, क्लासरूम में हम बहुत प्रैक्टिस करते हैं, राइट। अब ये क्वेश्चन देख लीजिए, द वैल्यू ऑफ दिस वन, ये कॉम्प्लेक्स इंटीग्रेशन है। सो कॉम्प्लेक्स इंटीग्रेशन का सेम फंडा बेटा हम जीटीक्यू में भी किया था। तो यहां पर क्या करना है, ये पोल्स निकालना है। यहां पोल 2 आएगा, एक 0 और एक 2, राइट और नॉट, बट दिस इज रिपीटिंग ट्वाइस। बट यहां पर एक प्रॉब्लम हो सकता है, देखो ये जब जेड इज इक्वल टू 0 के लिए जब न्यूमरेटर देखते हैं ना, तो जो न्यूमरेटर 0 हो रहा है, और जब जेड इज इक्वल टू 2 के लिए न्यूमरेटर भी sin 2 पाई 0 हो रहा है। तो जब पोल के लिए, किसी भी पोल के लिए अगर न्यूमरेटर 0 होता है, तो उसका रेसिड्यूज कैसे लेना है, हम लॉरेंट सीरीज से निकालना है, लॉरेंट सीरीज से निकालना है। सो देयरफॉर दिस इंटीग्रल इज गिवन बाय 2 पाई बाय यूजिंग CRT, by CRT. So this integral is given by sum of residues. बट ये भी याद रखना है, हमारा कांटोर क्या है बेटा, मॉडुलस ऑफ z इज इक्वल टू 3 हियर। ये 0 है, ये -3 to 3 है, ये -3 to 3 है। अब यहाँ पोल्स है कि z इज इक्वल टू 0, राइट। एक पोल है z इज इक्वल टू 0, राइट और नॉट, और दूसरा पोल क्या है 2। सो 2 तो यहाँ है, सो दोनों अंदर ही है ना, सो बोथ पोल्स आर लाइस इनसाइड। सो देयरफॉर वी हैव टू फाइंड द रेसिड्यू एट 0 एंड वी हैव टू फाइंड द रेसिड्यू एट 2 here. So by using the Lorentz series expansion of this function, so we are getting this residues, okay, that is of 2 pi I into, so we are getting this residues as, this one is minus pi by 2, you get it. So one is of minus pi by 2, you get it, and another one is that 0. So this will be the answer, minus pi I square by 2, okay. Minus 2 is also getting cancelled here, so you are getting only pi I square. So minus I pi square is the right answer for this question here. Okay, ये भी डायरेक्ट क्वेश्चन है बेटा, फार्मूलास लेकर के भी कर सकते हैं। अगर आप नॉर्मल से फार्मूलास लेकर भी यूज किए, अगर पार्शियल फ्रैक्शंस के बिना, Lorentz series के, without using the Lorentz series, suppose if you are doing it by normal, so direct using the formula also you will get the same answer, that is minus I pi square. Okay, right. So that's it guys. So these are the number of questions from engineering mathematics side. So I hope everyone has done the the mathematics questions very well, and this is some, those who have studied in our class, so I think everybody got good answers and almost all the questions. And there is one more probability questions we got, that is simply you can get it as a half pi by 2, that was discussed by communication system faculty, right. So next subject will be taken on, right. Thank you.
So dear students, now we are going to discuss electronic devices questions. So one by one we will discuss all the questions that we have got from the students. Okay. So start from the first question.
In a solar cell, voltage corresponds to maximum voltage point. This point is you need to consider what we have got. It is maximum voltage point, right? Some students have written maximum power, but it should be maximum voltage point. So on graph, if you see maximum voltage, the graph is something like this. So maximum voltage point, it means you have been given VOC, open circuit voltage, and that is 0.3 volt. And then you have been given photo current. So photo current I used to write sometimes IPH or ISC, short circuit current you can say. So that is 1 milliampere. One important thing which you have to observe, thermal voltage is given 30 millivolt. So VTH is equal to 30 millivolt. Now there is nothing in the question, you can use directly the formula.
for this current, and that formula is something like this: VOC is equal to VTH ln 1 plus ISC, IPH, whatever you write, and IS, that is reverse saturation current. You simplify this, you can ignore this one, or you can even take that. Let us suppose we ignore this. So VOC, it is VTH, and then ln ISC and IS. So let us take the anti-log of both sides, so it will become VOC upon VTH, and this is equal to ISC upon IS, and when I calculate IS from this, so it comes out as ISC divided by e to the power VOC upon VTS. Now put these values. ISC is 1 milliampere and e to the power VOC. VOC is 0.3 volt, and this 30 millivolts. So 30 into 10 raised power minus 3. Answer was asked in nano ampere. So how much is the answer, sir?
40. So you will get 45.30 nano
ampere. This would be the answer for this question. So next question.
Okay, so next question is about MOS capacitор. So P substrate MOS capacitор was mentioned. Oxide thickness TOX was given 100 nanometer, and oxide charge are given 10 to the power minus 8 coulomb per centimeter square, and work function energy of the metal is given. So work function energy Q phi m is given 4.6 electron volt. Okay, and epsilon OX given. Flat band voltage mentioned equal to 0. Flat band voltage is given is equal to 0. We have to calculate work function energy of the semiconductor. Now see, first of all, oxide charges are given, that is QOX is given 10 to the power of minus 8 coulomb per centimeter square. So we can calculate oxide charge divided by COX, because flat band voltage के फॉर्मूले में हमें इसकी नीड पड़ने वाली है, because flat band voltage is equal to oxide charge divided by COX and plus work function difference between metal and semiconductor. Now if we are writing in the format of voltage, we can write directly phi ms work function difference between metal and semiconductor. Okay, so now QX upon COX हम calculate करेंगे. QX की वैल्यू रखी मैंने 10 to the power minus 8. COX is the oxide capacitance. मुझे COX की नीड है, तो COX is equal to epsilon OX upon TOX. epsilon OX की वैल्यू गिवन है 4 epsilon naught. 4 into epsilon naught रख देता हूँ 8.85 into 10 to the power of minus 14 farad per centimeter, and divide by oxide thickness is 100 nanometer. Convert 100 nanometer in centimeter. So 100 into 10 to the power minus 9 into 100, and we will get it in the centimeter. So COX we will get how much COX? So COX we will get 35.4 into 10 to the power of minus 9 in farad per centimeter square. This is the value of COX. Now COX is known, so COX we can put over here 35.4 into 10 to the power minus 9. तो यहाँ से हमें QOX upon COX मिल जाएगा, that is 10 upon 35.4 volt. This is the value of QX upon COX. Now flat band voltage की equation पर चलते हैं हम. So what is flat band voltage? So flat band voltage is equal to QOX upon COX divided by plus work function difference between metal and semiconductor. ये वोल्टेज गिवन है, फ्लैट बैंड वोल्टेज 0. अब QX अपॉन COX आपको पता होना चाहिए कि फ्लैट बैंड वोल्टेज के फॉर्मूले में मैंने आपको सिखाया है, जो भी साइन चार्ज का होता है उसका जस्ट उल्टा होता है चार्ज अपॉन कैपेसिटेंस का वैल्यू. ओके, तो QX कितना दिया है 10 to the power minus 8. पॉजिटिव चार्ज गिवन है ऑक्साइड के अंदर, तो डेफिनेटली Q अपॉन COX कैसा होगा? नेगेटिव. तो जो भी आपको QX अपॉन COX दिख रहा है, अगर ऑक्साइड चार्ज पॉजिटिव है, डायरेक्टली बिना दिमाग लगाए साइन को रिवर्स कर दिया करो, और उसका लॉजिक आपको पता है. सो दिस इज द वैल्यू प्लस phi ms. अब मुझे phi ms मिल गया, मुझे कितना 10 अपॉन 35.4. ओके, नाउ सी वर्क फंक्शन डिफरेंस क्या होगा? phi m माइनस phi ऑफ s 10 अपॉन 35.4. मेटल का वर्क फंक्शन गिवन है, मेटल का वर्क फंक्शन Q phi m 4.6 है, तो Q phi m गिवन है 4.6 इलेक्ट्रॉन वोल्ट में, तो वोल्ट में क्या हो जाएगा पोटेंशियल के फॉर्मेट में 4.6 वोल्ट डायरेक्टली. तो यहां पे मैं रख देता हूं ये 4.6, ये माइनस फाइव एस को उधर लेके चला जाता हूं, तो आ जाएगा 10 अपॉन 35.4 प्लस 5s.
यहां से phi s निकाल देता हूं मैं, तो phi s आ जाएगा आपका 4.6 माइनस 10/35.4। अब ये आंसर जो है वो पोटेंशियल के फॉर्म में है, पोटेंशियल या मैं बोल सकता हूं सेमीकंडक्टर के वर्क फंक्शन एनर्जी को पोटेंशियल के फॉर्मेट में देखें तो इतना है, और पोटेंशियल एनर्जी के फॉर्म में लिखें तो Q phi s बोल देंगे, बिकॉज इसकी यूनिट अभी वोल्ट है और इलेक्ट्रॉन वोल्ट में Q phi s लिख सकते हैं। इसको सॉल्व करेंगे रफली कितना आएगा सर, 4.3 इलेक्ट्रॉन वोल्ट के आसपास आएगा। यहां तक सॉल्यूशन को देखें आप ध्यान से, इसके बाद ये जस्ट कैलकुलेशन है, सो अप्रोक्सीमेटली 4.3 इलेक्ट्रॉन वोल्ट। ओके, नेक्स्ट क्वेश्चन।
Very simple question. For an n-type semiconductor, the doping concentration of graph is given. So here you have to see at the y-axis it is in terms of log, and at the x-axis it is in terms of 1/temperature. So this is not properly drawn exact, but this is the correct answer. This cannot be possible, this cannot be possible, this cannot be possible. The graph is something like this. So this is the correct answer, and there you may have got the right option. So 1 mark question, very easy.
ओके, अगर इस क्वेश्चन में आप बात करें तो ये 1/t के फॉर्म में गिवन है। अगर किसी बच्चे ने टी के फॉर्म में पढ़ा हो, मान लो कि लॉग ऑफ कॉन्सेंट्रेशन ऑफ चार्ज कैरियर इलेक्ट्रॉन कॉन्सेंट्रेशन वर्सेस टी, तो उसने कभी ये प्लॉट इस टाइप से पढ़ा होगा, तो वो ध्यान रखे कि ये प्लॉट तब आता है जब टी के फॉर्मेट में आप प्लॉट करते हैं। 1/t के फॉर्मेट में गिवन है, जैसे उसका रिवर्स कर दिया आपने, वही आपका आंसर आ जाएगा।
इनफैक्ट जिन्होंने मुझसे पढ़ा होगा तो मैंने यही आपको पढ़ाया होगा, लेकिन एक क्वेश्चन मैं कराता हूँ शायद RIB और बुक में या कहीं पर, जो 1/t के फॉर्मेट में है। तो आप अगर ये भी ग्राफ जानते हैं तो ये t के फॉर्मेट में है, इसका रेसिप्रोकल करना है, तो जहां t इंक्रीज कर रहा है वहां डिक्रीज करके इस लॉजिक से भी सॉल्व कर सकते हैं। आगे बढ़े।
Okay, so this is the question. In a semiconductor, the concentration graph with the distance x is as shown in the figure. तो इलेक्ट्रॉन का concentration versus distance x का प्लॉट गिवन है। मीनिंग इज दैट इलेक्ट्रॉन concentration A से C में नॉन यूनिफॉर्म है और C से B में भी नॉन यूनिफॉर्म है, और नॉन यूनिफॉर्मली डोप्ड सेमीकंडक्टर कॉन्सेप्ट आपको पता है, डिफ्यूजन करंट भी आता है, ड्रिफ्ट भी आता है, दोनों एक दूसरे को बैलेंस करते हैं, नेट करंट 0 होता है और एक इंटरनल इलेक्ट्रिक फील्ड एग्जिस्ट कर रही होती है। ये उसी का क्वेश्चन है। तो 1 by 1 देखते हैं हम। तो पहला जो ऑप्शन है A एंड B, उसको कंसीडर करते हैं हम। तो A और B में वो किस रीजन की बात कर रहा है, बिटवीन B एंड C। तो B एंड C वाला प्लॉट देख लेता हूं मैं, B और C का प्लॉट ये है, तो B और C वाला प्लॉट बना लेता हूं सबसे पहले। सो बिटवीन B एंड C देख रहा हूं मैं। सो B एंड C के बीच में जो प्लॉट है वो ऐसा है, ये आपका C पॉइंट है और ये आपका B पॉइंट है, और यहाँ पर इलेक्ट्रॉन का कॉन्सेंट्रेशन है इस एक्सेस में और इधर डिस्टेंस है। मतलब क्या है, यहाँ पर इलेक्ट्रॉन का कॉन्सेंट्रेशन ज्यादा है, यहाँ इलेक्ट्रॉन का कॉन्सेंट्रेशन कम है। यहाँ बोलूं डोपिंग के फॉर्मेट में, यहाँ पर एन टाइप की डोपिंग ज्यादा है, यहाँ पर कम है। लेफ्ट साइड हेवली डोप्ड, राइट साइड लाइटली डोप्ड। तो डेफिनेटली क्या होगा, लेफ्ट साइड इलेक्ट्रॉन का कॉन्सेंट्रेशन ज्यादा है और राइट साइड इलेक्ट्रॉन का कॉन्सेंट्रेशन कम है। तो डेफिनेटली इलेक्ट्रॉन डिफ्यूज करेंगे लेफ्ट टू राइट साइड। इलेक्ट्रॉन डिफ्यूज करेंगे तो डिफ्यूजन करंट आएगा। क्वेश्चन में करंट्स के बारे में पूछा है, इलेक्ट्रिक फील्ड के बारे में पूछा है, तो उसके बारे में ही सोचना है हमें। तो इलेक्ट्रॉन इस डायरेक्शन में डिफ्यूज करेंगे तो करंट कैसा आएगा, ये ऐसा आएगा। इसको बोलेंगे हम इलेक्ट्रॉन का डिफ्यूजन करंट। ओके, अब इस इलेक्ट्रॉन के डिफ्यूजन करंट की डायरेक्शन क्या है, ये B है, ये C है। तो ये C है पॉइंट बेटा, ये B है। तो इलेक्ट्रॉन का डिफ्यूजन करंट B to C है। तो पहला ऑप्शन देखते हैं, इन बिटवीन B एंड C द डिफ्यूजन करंट इज फ्रॉम C to B, नो करंट इज फ्रॉम B to C। तो आपका A ऑप्शन क्या हो गया, गलत। B पे चलते हैं, इन बिटवीन B एंड C द डिफ्यूजन करंट इज फ्रॉम B to C, यस B to C है, तो आपका डेफिनेटली B वाला क्या हो गया, करेक्ट हो गया। अब C को देखते हैं, इन बिटवीन A एंड C, तो अब B और C के बारे में ज्यादा बात करनी नहीं है, सीधा A और C के बीच में चलते हैं। अब A और C के बीच में देखता हूं मैं, बिटवीन A एंड C। तो A एंड C के बीच में क्या हो रहा है बेटा, A और C के बीच में इलेक्ट्रॉन का कॉन्सेंट्रेशन वर्सेस डिस्टेंस का प्लॉट बनाऊं तो A और C के बीच में ऐसा है प्लॉट, ये पॉइंट A है, ये पॉइंट C है। अब उल्टा हो गया, यहां इलेक्ट्रॉन का कॉन्सेंट्रेशन ज्यादा है राइट साइड और लेफ्ट साइड कम है। मीनिंग इज दैट कि राइट साइड इलेक्ट्रॉन कॉन्सेंट्रेशन ज्यादा है, लेफ्ट साइड कम है। डेफिनेटली इलेक्ट्रॉन राइट टू लेफ्ट डिफ्यूज करेंगे। इलेक्ट्रॉन राइट टू लेफ्ट डिफ्यूज करेंगे, करंट हमेशा अपोजिट डायरेक्शन में आता है मूवमेंट के। तो इलेक्ट्रॉन का डिफ्यूजन करंट कैसा होगा, आई एन डिफ्यूजन इस डायरेक्शन में होगा। तो इसकी डायरेक्शन क्या होगी, ये A है, ये C है, तो डिफ्यूजन करंट की डायरेक्शन क्या होगी, A to C। क्या डिफ्यूजन करंट से रिलेटेड कोई ऑप्शन है क्या, नहीं। ड्रिफ्ट करंट और इलेक्ट्रिक फील्ड के बारे में पूछ रहा है। अब आगे बढ़ते हैं, ये डिफ्यूजन करंट है, लेकिन आपको पता है ड्रिफ्ट करंट भी आता है इलेक्ट्रिक फील्ड की वजह से। तो पहले इलेक्ट्रिक फील्ड के बारे में सोच लेते हैं। जब इलेक्ट्रॉन यहां से डिफ्यूज करेंगे तो इलेक्ट्रिक फील्ड की डायरेक्शन क्या होगी बेटा, इलेक्ट्रॉन अकेले तो अवेलेबल होते नहीं है एन टाइप में, क्या होते हैं, पॉजिटिव आयंस एंड इलेक्ट्रॉन। तो जब एक इलेक्ट्रॉन राइट टू लेफ्ट साइड डिफ्यूज करता है तो डेफिनेटली राइट साइड क्या बचे रह जाते हैं, अनकंपनसेटेड पॉजिटिव आयंस। लेफ्ट साइड आ जाते हैं आपके इलेक्ट्रॉन, और यहां पर क्रिएट हो जाती है एक पॉजिटिव चार्ज से नेगेटिव चार्ज की डायरेक्शन में एक इंटरनल इलेक्ट्रिक फील्ड। इनबिल्ट इलेक्ट्रिक फील्ड। तो इनबिल्ट इलेक्ट्रिक फील्ड क्या होगी आपकी डेफिनेटली इस डायरेक्शन में। इनबिल्ट इलेक्ट्रिक फील्ड डायरेक्शन क्या हो गई C2A। इलेक्ट्रिक फील्ड के बारे में देखो, इन बिटवीन A एंड C द इलेक्ट्रिक फील्ड इज फ्रॉम C2A। क्या C2A इलेक्ट्रिक फील्ड है? हाँ है, तो D को मैं सही लगा दूंगा। अब मेरे को ड्रिफ्ट करंट देखना है। अब देखना A to C डिफ्यूजन करंट आ गया, इलेक्ट्रिक फील्ड आ गया। अब ड्रिफ्ट करंट के बारे में बात करते हैं। इलेक्ट्रिक फील्ड ऐसा है तो ड्रिफ्ट कैसा होगा? चार्ज पार्टिकल इलेक्ट्रॉन, इलेक्ट्रिक फील्ड की वजह से एक फोर्स लगेगा जिसको हम बोलेंगे ड्रिफ्ट फोर्स। ये इलेक्ट्रॉन का ड्रिफ्ट है। अब करंट की बात करते हैं तो ड्रिफ्ट हुआ। अब करंट कैसा होगा? इलेक्ट्रॉन के अपोजिट डायरेक्शन में। ये करंट आ जाएगा इलेक्ट्रॉन का IN ड्रिफ्ट। तो अब बेटा ड्रिफ्ट करंट की डायरेक्शन क्या हो गई? ये राइट साइड C लेफ्ट साइड A, तो C to A डायरेक्शन में ड्रिफ्ट करंट है। तो क्या ड्रिफ्ट करंट C to A है? बिटवीन A एंड C द ड्रिफ्ट करंट इज फ्रॉम A to C। तो ऑप्शन C क्या हो गया? रॉन्ग। सो आपका B और D आपका क्या हो गया इस क्वेश्चन में? B एंड D आपका करेक्ट हो गया अकॉर्डिंग टू दिस क्वेश्चन एंड दिस सीक्वेंस ऑफ द ऑप्शन B एंड D आर करेक्ट। ओके, नेक्स्ट क्वेश्चन। ओके,
Which of the following options are correct? In low level injection, the beta decreases with increase in collector current. In high level injection, the beta decreases with the increase in collector current. Beta is in saturation less than the active region. Beta decreases with increased breakdown collector emitter voltage. It is also MSQ, I think.
Yes, MSQ. Shall I discuss? Okay. So which of the following options is or are correct? तो ये एक MSQ क्वेश्चन है और एक बहुत अच्छा क्वेश्चन है। देखो बेटा ध्यान से इसको। लो लेवल इंजेक्शन मींस जो भी आप EDC में जितना पढ़ रहे होते हैं ऑलमोस्ट 98% आप लो लेवल इंजेक्शन में ही पढ़ रहे होते हैं। बाकी अलग से बिल्कुल डिस्कशन होता है हाई लेवल इंजेक्शन का। हाई लेवल इंजेक्शन और लो लेवल में डिफरेंस क्या है? हाई लेवल मींस व्हेन एक्सेस कैरियर कॉन्सेंट्रेशन इज कंपेरेबल टू मेजॉरिटी कैरियर कॉन्सेंट्रेशन, वी विल कंसीडर द high level injection condition. Or when excess minority carrier concentration is below thermal equilibrium value of majority carrier concentration, then it is a low level injection condition. ठीक है, तो होता क्या है बेटा? ऑप्शन से देखें हम बीजेटी के फॉर्म में, तो बीजेटी में आपका जो बीटा होता है और कलेक्टर करंट होता है उसका अगर मैं प्लॉट बनाऊं बीटा वर्सेस आईसी, एक स्टैंडर्ड प्लॉट है। होता क्या है अगर इस प्लॉट को देखें तो ये इस टाइप से होता है। तो जो आप बीटा पढ़ते हैं ना कहीं भी किसी भी बीजेटी क्वेश्चन में, वो इस रेंज ऑफ आईसी के लिए डिफाइन रहता है। लेकिन लो वैल्यू ऑफ आईसी पर बीटा इंक्रीज हो रहा होता है, फिर बीटा कांस्टेंट, और हाई वैल्यू ऑफ आईसी पर बीटा डिक्रीज हो रहा होता है। सो मेनली अगर मैं बात करूं इधर की, तो ये वाला जो पोर्शन होता है वो हाई लेवल इंजेक्शन वाला होता है। हाई लेवल इंजेक्शन, हाई लेवल इंजेक्शन। और हाई लेवल इंजेक्शन के केस में क्या होगा? हाई लेवल इंजेक्शन के दो केस हो सकते हैं, या तो आपने अमीटर बेस जंक्शन पर वोल्टेज बहुत हाई लगाया है, या फिर आपने अमीटर की डोपिंग बहुत हाई की है। अगर अमीटर हेवली डोप्ड है या अमीटर बेस जंक्शन का फॉर्ड वाइज ज्यादा है तो डेफिनेटली आपकी हाई लेवल इंजेक्शन कंडीशन बन सकती है। और उस हाई लेवल इंजेक्शन कंडीशन में क्या होता है कि जो भी अमीटर से चार्ज पार्टिकल डिफ्यूज होकर बेस में आ रहे हैं उनका जो एक्सेस कैरियर कॉन्सेंट्रेशन है वो जो बेस के अंदर थर्मल इक्विलिब्रियम मेजॉरिटी कैरियर कॉन्सेंट्रेशन है उससे ज्यादा हो सकता है या कंपेरेबल हो सकता है, जिसकी वजह से क्या होता है बेस के अंदर रिकॉम्बिनेशन प्रोसेस बहुत ज्यादा डोमिनेट हो जाती है। और रिकॉम्बिनेशन प्रोसेस डोमिनेट होने का मतलब क्या है? रिकॉम्बिनेशन करंट बढ़ जाती है। रिकॉम्बिनेशन करंट बढ़ने का मतलब क्या है? बेस करंट बढ़ जाती है। तो एट हाई लेवल इंजेक्शन कंडीशन जब आपकी अमीटर की डोपिंग हाई कर दें या बेस अमीटर जंक्शन का वोल्टेज बहुत ज्यादा लगा दें, उस केस में आपका बेस के अंदर रिकॉम्बिनेशन बढ़ने की वजह से बेस करंट बढ़ जाता है। आपका बेस करंट बढ़ेगा तो डेफिनेटली क्या होती है? आपकी कलेक्टर करंट कम हो जाती है। इसीलिए हाई लेवल इंजेक्शन कंडीशन में आपका क्या होता है कि जैसे जैसे मैं आपका क्या करता जाता हूं कलेक्टर करंट को बढ़ाने की कोशिश कर रहा हूं मैं, नो डाउट यहां पर डिक्रीज लिखा हुआ है वो उस सेंस में नहीं है। आईसी बढ़ने का मतलब अपनी प्रीवियस वैल्यू से बढ़ रहा है, जितना भी बढ़ाता जाऊंगा वो अपनी प्रीवियस वैल्यू से बढ़ रहा है। बेस के अंदर रिकॉम्बिनेशन आपका बढ़ता जा रहा है। परसेंटेज के हिसाब से देखा जाऊं तो फाइनली आईसी धीरे धीरे बढ़ रहा है, लेकिन उतना नहीं बढ़ रहा जितना बढ़ना चाहिए वीवी बढ़ाने से। ये मीनिंग है इसका। तो होता क्या है बेटा ध्यान से समझना, तो इसीलिए क्या होता है कि जब बेस में रिकॉम्बिनेशन ज्यादा होगा तो बेस में पार्टिकल रिकम्बाइन होगा, कलेक्टर पे कम पहुंचेंगे तो आपका बीटा की वैल्यू क्या हो जाती है? हाई वैल्यू ऑफ कलेक्टर करंट पर क्या होने लगती है? डिक्रीज होने लगती है ये। और बाकी का ये वाला पोर्शन रहता है ये लो लेवल इंजेक्शन कंडीशन का होता है। तो लो लेवल इंजेक्शन कंडीशन में तो पहला ऑप्शन देखते हैं, इन लो लेवल इंजेक्शन कंडीशन द बीटा डिक्रीजेस विथ इंक्रीज इन कलेक्टर करंट। मतलब क्या बोल रहा है कि बीटा की वैल्यू डिक्रीज हो रही हो और कलेक्टर करंट इंक्रीज हो रही हो। क्या ऐसा होता है क्या? आप तो देख लो बीजेटी का बेस टू मीटर वोल्टेज बढ़ाऊंगा मैं, डेफिनेटली कलेक्टर करंट बढ़ेगी। अगर मैं बीटा के हिसाब से देखूं तो बीटा ज्यादा होता है तो कलेक्टर करंट ज्यादा होती है, यही नॉर्मली आप पढ़ के आए हो, उसी को बोलते हैं लो लेवल इंजेक्शन, जिसमें बीटा बढ़ता है तो कलेक्टर करंट बढ़ती है। इसका मतलब ये गलत है। लो लेवल इंजेक्शन मतलब जिसमें आपका दिमाग काम करता है अभी तक, ठीक। अब इसमें चलते हैं। इन हाई लेवल इंजेक्शन द बीटा डिक्रीजेस विद इंक्रीज इन कलेक्टर करंट, यही तो पढ़ा अभी मैंने ग्राफ में। यस करेक्ट है, हाई लेवल इंजेक्शन होगा तो कलेक्टर करंट ज्यादा और कलेक्टर करंट ज्यादा और बीटा की वैल्यू डिक्रीज हो रही होगी बिकॉज बेस में रिकॉम्बिनेशन ज्यादा हो रहा होगा। नेक्स्ट, बीटा इन सैचुरेशन रीजन इज लेस देन इन एक्टिव रीजन, ठीक है। तो मतलब क्या बोल रहा है, सी को देखते हैं हम, सी वाले ऑप्शन को बताने के लिए, ठीक है। अब बेटा होता क्या है कि बीटा जो एक्टिव रीजन में होता है उसकी वैल्यू ज्यादा होती है किससे, बीटा इन द सैचुरेशन रीजन। क्यों होती है ऐसा, आपको पता है कि सैचुरेशन रीजन में क्या होता है, कलेक्टर करंट आपकी सैचुरेट हो जाती है। तो अगर बीटा की बात करूं तो बीटा क्या होता है बेटा, IC अपॉन IB। सैचुरेशन रीजन में आपने एक एनालिसिस एनालॉग में पढ़ा होगा, अगर आपने मेरी क्लास अटेंड की है उसमें, तो मैंने पढ़ाया है उसमें कि जैसे जैसे मैं बेस पे वोल्टेज बढ़ाता जाता हूं या बेस करंट को बढ़ाता जाता हूं तो बेस करंट तो कंटिन्यूअसली बढ़ती जाती है, लेकिन कलेक्टर करंट जो है ना वो एक लिमिट तक ही बढ़ती है। उसके बाद कलेक्टर करंट आपकी सैचुरेट हो जाती है और हम बोलते हैं ट्रांजिस्टर इज मूव्ड इनटू द सैचुरेशन रीजन। तो सैचुरेशन रीजन में कलेक्टर करंट के सैचुरेट हो जाने की वजह से जो बीटा है उस पर क्या इंपैक्ट पड़ेगा, बेस करंट कीप ऑन इंक्रीजिंग और बीटा की वैल्यू लो हो जाती है। दिस इज द केस ऑफ सैचुरेशन। बट इन द केस ऑफ एक्टिव रीजन, एक्टिव रीजन में कलेक्टर करंट आपकी फिक्स नहीं होती। जैसे जैसे बेस करंट बढ़ाता जाता हूं कलेक्टर करंट भी बढ़ती जाती है इन सच अ वे दैट बीटा कीप ऑन इंक्रीजिंग। अगर हम ऐसे देखें तो क्लियर है बात। इसका मतलब इन द एक्टिव रीजन बीटा की वैल्यू हाई होती है कंपेयर टू सैचुरेशन रीजन। इसलिए सी ऑप्शन को देखें हम, बीटा इन सैचुरेशन रीजन इज लेस, कम होता है कंपेयर टू एक्टिव रीजन। तो कंपेयर टू एक्टिव रीजन बीटा कम है, तो सी इज करेक्ट, बी इज करेक्ट, ए इज रॉन्ग। अब डी पर चलते हैं। देखो अब डी वाला जो पॉइंट है ना बेटा, ये थोड़ा बहुत ट्रिकी है, ठीक है ना। इसको तो एक बार सोचना पड़ेगा और हमें भी सोचना पड़ा, मुझे भी सोचना पड़ा। देखो क्या है कि आपने जनरली एक फॉर्मूला पढ़ा होगा ये वाला, BVCEO ओके इज इक्वल टू BVCBO मल्टीप्लाई बाई 1 अपॉन बीटा की पावर 1/n। अगर आप यहां से देखें कि बीटा और BVCEO में क्या रिलेशन है, अब पहले BVCEO को प्रोनाउंस करो। BVCEO है ब्रेकडाउन वोल्टेज ऑफ कलेक्टर टू अमीटर रीजन व्हेन बेस इज लेफ्ट ओपन, बेस इज लेफ्ट ओपन, और ये डिपेंड कर रहा है बीटा पर। अगर देखा तो बीटा और इसमें इनवर्स रिलेशन है, तो आप बोलेंगे बीटा हाई तो ये कम, बीटा लो तो ये हाई। लेकिन बेटा ये बेस ओपन है और ये वाला BVCEO का मतलब अमीटर ओपन है, क्या उसने ओपन वगैरह की कोई बात बोली है। अब ये डिपेंड करता है कि उसकी थिंकिंग क्या चल रही है क्वेश्चन बनाने वाले की। अगर वो इसी चीज को सोच रहा है तो फिर बीटा और BVCEO आप इनवर्स मान के ये ऑप्शन को देखेंगे तो वो उसके हिसाब से आंसर आ जाएगा। लेकिन मैं जनरलाइज चल रहा हूं क्योंकि बीटा और ब्रेकडाउन वोल्टेज ऑफ अमीटर कलेक्टर जंक्शन, अमीटर कलेक्टर वोल्टेज बोला है उसने, तो ब्रेकडाउन ऑफ अमीटर कलेक्टर या कलेक्टर अमीटर और बीटा के बीच में रिलेशन बोला है, तो थोड़ा कुछ केयर करने की जरूरत है। वो केयर क्या है देखते हैं बेटा। अब आपको ये बात पता करना है कि बीटा और कलेक्टर अमीटर के ब्रेकडाउन में क्या रिलेशन है। ये प्लॉट आपने पढ़ा है, कलेक्टर करंट IC वर्सेस VC का प्लॉट इन द कॉमन अमीटर। ये प्लॉट जब पढ़ाया आपने तो आपको, मैंने जब EDC पढ़ाया होगा तो मैंने ये प्लॉट पढ़ाया आपको कि व्हाट इज द ब्रेकडाउन वोल्टेज BVCEO, और जिसको क्या बोलते हैं ब्रेकडाउन वोल्टेज ऑफ रिवर्स वाइज कलेक्टर जंक्शन इन कॉमन अमीटर कॉन्फ़िगरेशन व्हेन बेस इज लेफ्ट ओपन, ठीक है। और ये जो प्लॉट आता है वो कब आता है, जब बेस करंट की वैल्यू 0 है। लेकिन अगर मैं बेस करंट को बढ़ाऊं तो फिर ब्रेकडाउन क्या आएगा, कम वोल्टेज पर आ जाएगा। बेस करंट को और बढ़ाऊं तो और कम पर आ जाएगा। इसका मतलब ये बेस करंट लो है, ये बेस करंट ज्यादा पर है और ये बेस करंट और ज्यादा पर है। मतलब यहां से यहां तक देखूं तो बेस करंट बढ़ रहा है और ब्रेकडाउन वोल्टेज कम हो रहा है। ये ब्रेकडाउन वोल्टेज ज्यादा, ब्रेकडाउन वोल्टेज और कम, ब्रेकडाउन वोल्टेज और कम। तो मीनिंग इज दैट ये प्लॉट आपको कंक्लूड करके बोल रहा है कि व्हेन बेस करंट इंक्रीजेस ब्रेकडाउन वोल्टेज ऑफ कॉमन अमीटर, यस और नो, कलेक्टर टू अमीटर ब्रेकडाउन वोल्टेज ये डिक्रीज हो रहा होता है आपका। क्लियर है बात। अब अगर ऐसा है, अब मैं यहां से चलने वाला हूं, वो भी हो सकता है, ये डिपेंड करता है कि उनकी थिंकिंग क्या है क्वेश्चन बनाने वाले की, ठीक है। अब अगर यहां से चलें, बेस करंट ज्यादा तो BVC आपका क्या होगा, ब्रेकडाउन वोल्टेज कम होगा। अब बेस करंट ज्यादा, अब मैं बीटा तक पहुंचना है हमें। अब बीटा क्या बोलता है, क्योंकि एक्चुअली प्रैक्टिकली जब हम लैब में बात करते हैं तो बीटा का एक्सट्रैक्शन इसी प्लॉट से किया जाता है। ये अलग अलग वैल्यू ऑफ बीटा के लिए भी हो सकते हैं ये प्लॉट, अलग अलग बेस करंट मतलब अलग अलग बीटा। अब बेटा बताओ बेस करंट ज्यादा कब होता है, जब अगर बेस में रिकॉम्बिनेशन ज्यादा हो। बेस में रिकॉम्बिनेशन ज्यादा कब होता है, जब बीटा स्मॉल हो। बीटा स्मॉल होने की मतलब है बेस करंट ज्यादा, कलेक्टर करंट कम। तो बीटा अगर स्मॉल है तो बेस करंट ज्यादा है, और बेस करंट ज्यादा है तो ब्रेक डाउन वोल्टेज कम है। फिर यहां से क्या देखा आपको, ब्रेक डाउन वोल्टेज और बीटा का रिलेशन एक जैसा, बीटा कम तो ब्रेक डाउन कम वोल्टेज पर, बीटा ज्यादा तो ब्रेक डाउन ज्यादा वोल्टेज पर। तो अगर इस सेंस से देखा जाए तो इस ऑप्शन में फिर क्या देखने को मिल रहा है कि बीटा डिक्रीजेस विद इंक्रीज इन ब्रेक डाउन कलेक्टर अमीटर वोल्टेज। तो इसका मतलब क्या, फिर ये ऑप्शन गलत हो गया। बस अब चीज ध्यान रखना कि मैंने डिस्कस तो कर दिया इस चीज को, ये डिपेंड करेगा कि पेपर बनाने का थॉट प्रोसेस क्या है, वो क्या सोच रहा है। कई बार वो भी गलत सोच सकते हैं, ऐसा भी हो सकता है कि क्वेश्चन बनाते समय हमारा दिमाग 4 डायमेंशन में चल रहा होता है, अगर उसने ये डायमेंशन नहीं सोची होगी तो फिर बात अलग हो सकती है। ठीक है, चलो कोई बात नहीं।
वेरी सिंपल क्वेश्चन, इसमें आपको मॉस लीनियर रीजन में ऑपरेटिंग पॉइंट दिया हुआ है एंड म्यू एन सी ऑक्स डब्ल्यू बाई एल की वैल्यू दी हुई है, बीजीएस कांस्टेंट कह रहा है, देन बीडीएस की वैल्यू दे रहा है और आपसे ट्रांसकंडक्टेंस पूछ रहा है। पहले एक चीज देखें कि ये जो वैल्यू दी हुई है क्यों दी हुई है, यहां से हम कुछ फाइंड आउट कर सकते हैं। लीनियर रीजन में आपको करंट पता है, तो लीनियर रीजन में करंट की इक्वेशन हमारे पास क्या होती है, दैट इज आईडीएस mu n C ox W by L and this VGS minus VTH into VDS minus VDS square by 2, right? All these values are available with us. मैं ये सब values put नहीं कर रहा हूँ, ये put करके और यहाँ से आप VGS minus VTH निकाल लेंगे। This value you can calculate from here. This value comes out कितना आ रही सर, क्योंकि हम लोगों ने बहुत टाइम ले लिया।
VGS minus
BGS minus VTE, it is 1 point something we are getting. It is 1 point, I think
1.05.
1.05. Now, the key in the question is कि he is saying BGS is constant, but BDS is increasing. So if BDS is increasing, now for the new value of BDS, you see BDS is equal to 1.5 volt. This is greater than BGS minus BTH, which indicates that now transistor has entered into saturation region. So if transistor has entered into saturation region, then transconductance you can calculate at GM is equal to mu n C ox W by L and BGS minus VTH. All these values are available. This mu n C ox W by L, it is given as 50 microampere per volt, and this BGS minus BTH, since BGS is constant, so this value will remain same, so it is 1.05, and you when do you multiplication, it is 52 point something, I think 52 point some value you can get this value, I don't remember, you please do the multiplication. So 52 point something,
GM is 52.5 microampere per volt.
52.5 microampere per volt per volt. That is the value of GM. So these were the question. One question we got half data, so we are not discussing that. The complete data we are not getting. So overall opinion about the paper is, as far as EDC is concerned, 1 or 2 questions were little bit on the higher end, and remaining questions were doable. But overall paper was a little bit lengthy and a little bit difficult. So even if you are scoring less, don't worry. Even on less score, you are going to get a good rank, because paper was difficult. What I have analyzed, what our team has analyzed, it was not very simple paper. It was
above
difficult
moderate.
as compared,
Above moderate, we
right?
can.
It was difficult as comparison to last year.
Last year was very
easy.
simple.
So
Okay,
this
don't
paper was
expect that
difficult.
last year score ही आपका जाने वाला है, no.
हाँ,
उससे कम रहने वाला है जितना हमको लगता है।
बिल्कुल।
बाकी कोई एक आध स्टूडेंट बहुत ब्रिलियंट निकला है तो कुछ नहीं कह सकते।
2-4-10 लोग आउट ऑफ द बॉक्स होते हैं, बाकी ऑन एन एवरेज पेपर वाज डिफिकल्ट। थैंक यू।
ओके।
Dear students, I hope you have done well in today's GATE paper. I am Iftikhar Ahmed and I have Rajkumar sir with me, and we both will discuss some of the questions which came in today's GATE paper. From the data collected from students, we came to know there are about 7 questions from analog, and for some questions we could not get proper data. So those questions where we got data in a proper way, we will try to solve. Okay. First I will discuss couple of questions and then Rajkumar sir will discuss remaining questions. Let us come to the first question. It is a Zener diode based question, and it is told that initially capacitor is charged up to 10 volt. Okay, capacitor voltage at t equal to 0 minus is 10 volt, and then some switch is shown here. That switch is closed at t equal to 0. Now when the switch is closed, then capacitor will start discharging in this way, and remember this 10 volt is greater than the breakdown voltage of the Zener diode. So initially you can consider Zener diode in breakdown. It will act like a constant voltage source 5 volt, and capacitor will start discharging, and remember capacitor will discharge up to 5 volt. Once capacitor voltage becomes 5, then Zener diode will be off, and then current in the circuit will become 0. Now probably in this question they have asked maximum power dissipation in Zener diode. Now remember, maximum dissipation will happen at the beginning of discharge operation. I mean at t equal to 0 you will have 10 volt here, and then current in the circuit will be maximum. So we need to consider maximum current here, which is like 10 minus 5 divided by 10k. So if I write maximum current, it will be 10 volt across capacitor minus 5 volt across Zener diode divided by 10k. This will become 0.5 milliampere, and probably they have asked maximum power dissipation. So if I write maximum power dissipation in Zener diode P max, it will be Vz into this I max. Vz is 5 volt here, and maximum current is 0.5 milliampere. If you multiply, it will be 2.5 milliwatt. So thinking that question is about maximum power dissipation in Zener diode, answer will be 2.5 milliwatts. So this was one question based on Zener diode, and I hope all of you have done it correctly in the exam. Then let's move to the next question. This one I think is already discussed in EDC. Question was about calculating transconductance. You need to find VGS minus VT from the available data, and then if you take VDS 1.5, then at that VDS 1.5 MOSFET will go into saturation. So by using transconductance formula of saturation, you can easily calculate transconductance. This question is already covered in EDC, so I will skip it, and I hope students have done these questions correctly. Then let's take up the next question. Now this one is a good question. It is based on small signal analysis of MOSFET. I keep telling in the class that small signal amplifiers are very important for the GATE, and this year we have 2 questions based on small signal amplifier analysis. Okay, this one is about input impedance, and there is another question about voltage gain calculation. So let me discuss this particular question. We have to find input impedance. So what we have to do here is we need to replace MOSFET with the small signal model, and there is nothing mentioned about channel length modulation, so we will ignore channel length modulation effect. Then let me make here small signal model. If I draw here small signal model, it will be in this way. We are replacing MOSFET with small signal model here. This is gate, voltage between gate and source, it will be VGS, and this is a dependent current source which will be GM into VGS. Then you can do remaining connections. As you can see here, drain is grounded. It is actually a MOSFET in common drain configuration. Drain is grounded. So let me do all the connections. Drain grounded. Then between source terminal and ground we have a capacitor CL. I will represent it as impedance ZL, and that ZL will be 1 upon j omega CL. Okay, and then you can consider this as V0, output voltage. Then between gate and source we can show another impedance Z1, which is nothing but reactance offered by capacitor C1. Okay, that Z1 will be 1 upon j omega C1. Then you can show here input voltage. Input is applied between gate and ground, and you can assume some input current here, let us say II. We have to find input impedance. As you know, input impedance will be input voltage divided by input current. तो पहले हम यहाँ पर input current को लिख लेंगे. Input current will be VI minus V0 divided by Z1. VI minus V0 divided by Z1. आप इसको इस तरह से भी लिख सकते हैं, VI upon Z1 minus V0 upon Z1. Let us take it as equation 1. Then we will write down expression for V0. What will be V0 here? It will be current into this element multiplied by ZL. Current in this path will be input current plus GM VGS. So if I write here V0, it will be input current plus GM VGS multiplied with ZL. अब आप इसको थोड़ा सा सिंप्लीफाई करना. V0 is equal to II into ZL plus GM VGS into ZL. GM VGS into ZL. अब आप VGS की प्लेस में लिख सकते हैं इनपुट करंट इंटू Z1. तो VGS को हम सब्स्टिट्यूट करेंगे इनपुट करंट इंटू Z1, II इंटू Z1 एंड दैट मल्टीप्लाइड बाई ZL. हमने बस यहाँ पर VGS की प्लेस में सब्स्टिट्यूट किया है II इंटू Z1. यू कैन टेक II कॉमन, इट विल बिकम V0 is equal to II इंटू ZL प्लस GM इंटू Z1 इंटू ZL. अब आप इस V0 को यहाँ पर सब्स्टिट्यूट करेंगे. ओके, देन दिस आई विल सब्स्टिट्यूट हियर. It will become input current equal to VI upon Z1 minus V0 को हम लिख देंगे II into ZL plus GM Z1 into ZL. This divided by Z1. Now you can rearrange it. अब आप II वाले टर्म को RHS LHS की तरफ लेकर जाइए. You take II term this side and take II common. Okay, इसको मैं यहीं पर लिख देता हूँ. If I take it, let me write it in this way. II equal to VI upon I will take this term this side, so it will become 1 plus ZL plus GM into Z1 into ZL, okay, divided by Z1, and that is equal to VI upon Z1. Okay, now you can simplify this further. For example, you can take LCM Z1 and simplify this, so it will become II into Z1 plus ZL plus GM into Z1 into ZL is equal to Vi. अब आप यहाँ से लिख दो Vi upon II. Vi upon II will be called input impedance, and that will be Z1 plus ZL plus GM into Z1 into ZL. Then you can substitute Z1 and ZL values, so it will be in this way. Zi equal to Z1 को हम लिख देंगे 1 upon j omega C1 and ZL is 1 upon j omega CL, and this will become minus GM divided by omega square into C1 into CL. So in this problem, input impedance will come in this way. It's a very good question. Those who know small signal analysis, they should be able to answer this question quite comfortably. And there were some more questions, like there was one question based on feedback concept. Open loop gain was given 40 and you were asked to calculate closed loop gain, and for that question we didn't get exact circuit diagram, so I'm not discussing it here, but you can use formula AOL divided by 1 plus beta AOL, and that will give you the closed loop gain value. So these were some of the questions which I have taken up, and there are some more questions which Rajkumar sir will take up, so please.
Thank you, Iftikhar sir, nice explanation. So dear students, remaining questions I'll try to solve it, okay. And this question only, no, is a common source amplifier. Also we have a very good question, this is a MOSFET question related to common source amplifier. In EC, I think we got very good number of questions and all questions are having good quality. Very happy to see this type of questions. You can see in this question there are two concepts have been mixed here. One is an amplifier concept, and the second one we have a current active load concept. If you see here, there is an active load. Just 1 minute. Yellow is okay, no? Blue. Yeah. This is an active load. It's not coming. Yeah. This is an active load we have. Who has been studied active load in analog electronics? This is a diode connected MOSFET we say. In diode connected MOSFET, if you see from here, we can write this MOSFET in equivalent of a resistance. The resistance can be written as 1 by GM, because for diode connected MOSFET the answer will be 1 by GM, resistance, equivalent resistance. This is RB, this is 1 by GM. You can shift this total 2 resistors to down now. You can bend it to the down, and you can write some AC model for this MOSFET. AC equivalent model if you write, we can find out the gain. Just roughly I am showing here the modeling, you can see. This is Vi. Next we have RS. Next to bend this total branch in the bottom side, this becomes RB, and the active load is 1 by GM. This will be bending in this branch, and we have next gate will be there. The gate is open here, and we have a current source at the output of MOSFET, that is GM into VGS. This is your VGS now from here to here. Next we have RD, which comes parallel to this RD, and this will be the output. So most of the students who know AC analysis, they will do very easily this question. The only thing is the student should know the active load basics, otherwise he will stuck in this problem. This is the modeling, simple modeling. Just you want the gain V0 by Vn, how much? First calculate V0, which will be minus GM into VGS. I think he has given this as GM1, you take this as GM2. This is GM2, MOSFET 2, this is GM1 I have taken. So GM2 into VGS into RD. This will be the output voltage from the KVL equation at the output loop. VGS whatever you have with respect to Vi, if you take a relation VGS divided by Vi, you will get a transfer function for that. So if you write VGS in terms of input Vi into, it's just like a voltage division rule we have to apply here, so that RB plus 1 by GM1 divided by RS plus RB plus 1 by GM1. So this is your VGS. Now you can find out the V0, substitute this VGS here, you will get directly, I am writing the answer, V0 by Vn in magnitude if you want, because in this question he asked magnitude. So you can remove that sign minus because it is a common source amplifier. So we have just GM2 will come, it is RB plus 1 by GM1 divided by RS plus RB plus 1 by GM1 into RD. I think like this you can solve this problem. So this is the gain for the circuit given in the problem. So this is one good question we have. Let us move to the next question. Okay. Let us move to the next question. Maybe in the options with LCM they have been simplified, maybe according to that you can see the option. I have not taken LCM for this, maybe options what they have given I do not know. You can see according to this, similarly you can answer this question. Okay. Next, moving to the next question. So this circuit is also very simple circuit. I think who has studied rectifiers, I think this question will be a very basic question. For a center tap full wave rectifier he has given. It is a center tap full wave rectifier. Turns ratio is unknown here. In this question we have to find N value. Then first logic here is input primary voltage we know already 10 sin omega t given. Only thing is secondary voltage Vs, if we can solve it, we can find out the turns ratio very easily. You take this as Vs, secondary voltage. Generally by taking center tap it will make half of Vm, it will become 2 Vm. The secondary voltage total actually is 2 Vm. Okay, the two diodes are ideal he said. So first he has given some information here is average voltage. The average voltage here VDC across the load is 2 Vm by pi. That will be equal to 2.5 by pi. First find out the VDC for the full wave rectifier. Pi will be cancelled. Your Vm will be 2.5 by 2. But we want here 2 Vm as a secondary voltage magnitude is again 2.5 volts. So 2 Vm we are getting as magnitude as 2.5 volts. Now N:1 ratio can be solved as V primary by V secondary is to 1. Apply this formula you will get the value. The primary voltage in this problem is 10. It is a 10 divided by secondary voltage is 2.5 is to 1. It will be 4 is to 1. So the problem answer will be 4 is to 1 will be the correct answer for this question. Okay. Okay. N is equal to 4 here. N is equal to 4. This question I think maximum students have done this type of questions. Only one more question I have to discuss. That question is from oscillator I think. Let us see the next question. So this is the question I got first initially. So they have been typed actually. But after discussion with some other students, they said this is not the question. This is not the question. So this question is just looking like an RC phase shift oscillator. Who has studied oscillators, they can tell direct answer. F0 is equal to 1 by 2 pi RC root 6 is the F0 value. And this is not the question. I am writing the correct question here. You can see. I think maybe the question is given like this: minus plus. We have some feedback here. This is R1 and this is R, and we have some capacitor and one resistor here RC, and next one resistor and one capacitor. Next we have some feedback voltage. This is your output voltage, and this is not ground, it is getting feedback to this.
Non-inverting connected to
Sorry, yeah, sorry.
back arrow. Back. This.
erase
Right side second row.
erase कर दे.
This one double, this arrow, back arrow.
Which one? This one? No. So erase. Array is changing. Back arrow. Just front.
No problem, discuss with this.
Yeah, so just see here, the screen is creating problem for me. So anyway, this
Back arrow.
we have a feedback from here, positive feedback. So this is the circuit actually. Okay. In this circuit, if you clearly observe here, after the op amp, we have two networks circuits they have given. One is one C and R, and after that one R and C. So the same circuit, which is a beta network given here, this beta network, if you observe in Made Easy workbook, EC and electrical you can observe it. This much circuit only they have given in oscillator chapter. Anybody have doubt, you can see in the workbook, Made Easy workbook. This much circuit they have asked in the workbook is find out the beta value actually. So if you can have some networks knowledge, if you can find beta, that is VF by V naught for that beta network, which is a RC and RC. The first C and R he has given, which is a high pass circuit. Next R and C has given, which is a low pass circuit. One phase lead and one phase lag he has given. If you can find using the networks nodal analysis, whatever you like, you find out this answer. Maybe I remember that the answer is 1 by 3 plus J some omega RC minus omega RC. Something you can expect like this, the answer, correct? In this answer, the beta value what we got after simplifying by using networks knowledge, here omega, if anybody asks you, the J term should be equal to 0, omega value if you want. So omega RC minus 1 by omega RC, if you can make it 0, that is the J term I have made it 0, you will get the omega naught value. Omega naught will become 1 by RC. So like that we will get the omega naught value relation. If you want F naught, or we can have F naught also, it will become 1 by 2 pi RC. Maybe if they give in radians per second, omega naught will be given in the option. If they give F naught, you can write 1 by 2 pi RC. So the second relation they are asking between R1 to R, what will be the relation? Then how I will find out is, as omega naught became 1 by RC, that is a natural frequency when you apply for the oscillator, the J terms will be gone. So simply the beta value will become 1 by 3. This is beta. As beta is known for us, the gain becomes 3. The gain will become 3. And this circuit, if you observe, it's a non-inverting type. So for non-inverting type, the gain formula is 1 plus feedback is R1 by R, which is equal to 3. You can apply the gain formula here. 1 plus R1 by R is equal to 3. Then R1 by R will become 2. Then R1 will become 2R. So this is the relation between R1 and R. If you see this type of answers, it is looking similar to the questions, similar to the question of Wien-Bridge oscillator. Wien-Bridge, how we have got the calculations, the same calculations we are getting here. Okay. Now Hiftikar sir, please come and tell about this question paper, how you felt, whether it's easy or difficult.
Couple of questions like small signal analysis questions were lengthy, but remaining questions were easy. And there was one more question I think on op amp. It was a combination of non-inverting Schmidt trigger and integrator.
Yeah. There is one more question, but options we have not understood clearly.
Exactly. The data was not given, not available to us properly.
First I think Schmidt trigger here.
Schmidt trigger is there.
It's a non-inverting Schmidt trigger,
yes,
which is connected to an integrator.
Yes.
Generally in books we say with capacitor, but they have given inductor.
Inductor
when it comes in input side and resistor in a feedback, we say it's an integrator.
So that question was also there. Maybe
so
when
IIC
people raise the question, we will provide exact solution for that.
Yeah.
So
the remaining questions are wonderful.
Yes.
EC, I think there are very good number of questions came.
Exactly.
Very happy as a teachers we taught for the EC students.
And one more thing, students, irrespective of your performance today, be prepared for the next Sunday's ESC prelims exam.
Yeah, don't disturb your mind.
Exactly. Don't demoralize yourself.
Whatever
No
you
matter how was your performance
Yeah.
today, keep preparing for ESC prelims, and hopefully you will do well in ESC prelims paper also.
Yeah.
So our
All the
best
be-
wishes to you.
All the best,
Thank you.
dear students. Thank you. Thank you very much.
Yeah.
So welcome everyone for the video solution of the question that was asked today's GATE exam. So the first question that we can see, there is some electric field is traveling in air in the positive x direction, is incident on perfect conductor normally incident at x equal to 0. That means there is a normal incidence. Value of x where magnetic field is 0, right? So the question is where magnetic field has to be 0 for the first time. Now if you look at the question, so it is basically, it is traveling in air and it is on the perfect conductor, right? So what is this? This is a perfect conductor. So if this is the perfect conductor, so how you are going to solve the question? So for this, suppose this is the x axis, right? So I will give you just brief solution. Detailed solution you can visit the website and then you can see, right? So this is the perfect conductor, right? This is the perfect conductor, fine, and this is the air, correct? So if I take reference to be here, let us take, we are taking reference at the interface. So since it is a perfect conductor, we know that gamma is equal to -1. It means that gamma can be written as in the format of mod of gamma at an angle theta gamma. So this is nothing but your what at an angle pi, correct? Now they are asking, if you look at the question, they are asking the magnetic field has to be 0. So that means magnetic field wherever it is the minima, the electric field has to be maxima, right? So that means wherever electric field is maxima, it means that there will be magnetic field will be minima, right? And this occurs at 2 beta x max is equal to 2n pi plus of theta gamma, right? So that means minimum electric field. So if you check here, what is the E max? So E max is nothing but your E naught 1 plus mod of gamma. And what is your H min? H min is your E naught upon eta 1 minus mod of gamma. So you can see that if I put mod gamma equal to 1, then you will get what? You are going to get magnetic field to be 0, right? So if I put gamma value, mod gamma is equal to 1, so 1 minus 1 0, so this is the magnetic field will become 0. So magnetic field becomes 0, that means minimum magnetic field, electric field is maximum, and these things occur at what value? These things will occur at this particular value, right? So therefore what you can do is, if I solve it, so therefore this is a 4 pi upon lambda into x max is equal to 2n pi. Theta gamma is how much? It is pi, right? So theta gamma is how much? It is pi. So this pi, this pi, this pi is getting cancelled. So what is the value of x max you are going to get? So you are going to get 2n plus 1 lambda by 4, right? Where n can start from 0, 1, 2, 3 and so on. Now the first they are asking, if you read the question, they are asking what is the first time. So first time means at n equal to 0. So if I put n equal to 0, you will get the first maxima. That means the distance. You can say that this is your lambda by 4, right? Now I have to find lambda. In the question they have given this value. You can see here this value is given. How much beta value is given? Beta is how much? 2 pi by 3, right? So I can say that beta is equal to 2 pi by 3. So beta can be written as 2 pi by lambda because it is in the air, which is equal to 2 pi by 3. So what is the value of lambda? It is equal to 3. So if it is 3, then x is equal to how much? It is 3 by 4, because this is lambda by 4. So this is the answer. Now this is the answer when I have kept reference at interface, right? So it will become x is equal to minus 3 by 4 when the reference is not at interface, right? So if you look at the options, they have given negative. Negative means if the reference has not been taken at the interface. So that means what should be the correct answer for this? So the answer correct is your B, minus 3 by 4, because all the calculation that we have done, it is taken with reference to the interface reference. If you take a reference here, right, then it will come minus of 3 by 4, correct? So what is the answer? So answer is your minus 3 by 4, correct? Next, coming to the next question, the load impedance is short circuited and they are asking the normalized impedance will be what? So what is the normalized impedance? Now this is the short circuit, right? This is short circuit. So what is a Z short circuit? It is equal to J times Z naught tan of beta L, right? So that what is the normalized? Normalized short circuit is equal to Z short circuit divided by Z naught characteristic impedance, which is equal to J times of tan beta L. Now here first of all say Z in A, right? So if I find Z in A, it is equal to J times tan of beta upon lambda into length is how much? It is lambda by 8. So this is how much? It is equal to J1. Similarly, Z in B is how much? It is a J of tan 2 pi by lambda into lambda by 4, right? So Z in B, so total distance will be how much? It will be lambda by 4, right? So this is how much? So this is your lambda and tan pi by 2, this is your infinity, correct? Next, Z in, so this is normalized, Z in C, it will be a J times tan 2 pi by lambda into 3, this is how much? Lambda by 8, lambda by 4, so this is your 3 lambda by 8, right? So this will come minus of J times of 1, right? Okay. Similarly, Z in D, normalized, this is again J times tan 2 pi by lambda into lambda by 2, right? So this is tan pi, it is 0, correct? So what should be the answer? J1 infinity minus J1 and 0. So that means A should be the correct answer for this particular question, right? Okay. Now coming to the next question, question number 3. A lossless transmission line Z0 is given, it is terminated with an unknown load, mod gamma is given as 0.6. As one moves towards the generator from the load, maximum value of the input impedance magnitude looking towards the load, obviously here mod gamma is given as 0.6, right? So therefore what is S? 1 plus mod gamma upon 1 minus mod gamma, this is equal to 1 plus 0.6 divided by 1 minus 0.6. So this is 1.6 divided by 0.4, which is equal to 4, right? So what is your Z max? So Z max is equal to S into Z naught. Standing wave ratio is 4, Z naught is given as 50. So what is the answer? It should be 200 ohms. So this should be the answer for this particular question, correct? Now coming to the last question that we have received, it is the for the given there are two vector field F1 and F2, then which is the electrostatic field? We know that if it is an electrostatic field, right? So if del cross F is equal to 0, it means it is your electrostatic field, right? It is your electrostatic field. That means you have to do, so when you solve del cross F1, right, it will come 0, and if I do del cross F2, it is non-zero. So that means it is simple calculation, you can do it. So the detailed solution you can see later on. So if I do del cross F1, so you will get 0, del cross F2 is non-zero. That means whichever is 0, that is electrostatic. That means F1 is electrostatic, not F2. So what is the answer? It is option B, right? So with this we conclude our video solution of this EC. So I hope you have done better and you have also done your best, right? So all the best for your future venture. So thank you.